Close your eyes and imagine yourself floating in a vast ocean of silence. There are no walls, no ceilings, no floor beneath your feet. Only the endless black canvas of the night sky, sprinkled with billions of stars. Each star is a sun, burning. In the far distance, whispering across unimaginable gulfs of time and space. You are weightless, drifting, as if you have become one with the cosmos itself. This is where our journey begins, the edge of human imagination, standing at the threshold of infinity. Tonight, as you listen, allow yourself to relax. Breathe deeply. Let the rhythm of your breath slow down. Feel the weight of your body sinking gently into the surface beneath you. You are safe. You are calm. You are here. And yet, at the same time, you are everywhere. For centuries, humankind has gazed at the night sky, asking questions too large for any single lifetime to answer. Does the universe have an edge? What lies beyond the farthest star? Is infinity a place, a number, a mystery, or simply an illusion created by our limited minds? These questions are not just scientific, they are profoundly human. They echo within us because they remind us that we are small, yet connected to something immeasurably vast. Tonight's journey is not about finding a final answer. It is about traveling together, step by step, thought by thought, across the horizons of knowledge and wonder. It is about embracing the mystery, letting the unknown wash over us like a gentle tide. So as we begin, imagine that you are no longer in a room, no longer on Earth, no longer bound by the everyday noise of life. Instead, you are seated at the very edge of time, looking outward into eternity. The stars shimmer, the galaxies swirl, and the infinite whispers softly, inviting you closer. Let us set forth, slowly and quietly, into the edge of infinity. Imagine yourself thousands of years ago, long before cities, long before machines, long before the noise of the modern world. Night falls, and above you, the heavens awaken. There are no streetlights, no artificial glow, the pure darkness of the sky and the brilliant fire of the stars. For the first humans, this sight was overwhelming. It was terrifying. And it was beautiful. They looked upward and saw a dome of light so vast that words could not describe it. The stars did not flicker randomly, they moved. They shifted, they traced patterns across the heavens. The moon grew full, then vanished, then returned again, marking time in silent cycles. The sun rose and set, ruling over life with its warmth. For those who watched the skies, there was only one conclusion: above us lies the infinite. But what was infinity to them? It was not a number, not an equation, not something measured in light years. Infinity was mystery. It was a god, a spirit, a realm beyond the reach of mortals. In Babylon, priests stood atop great ziggurats, observing the motion of the stars, believing they were messages from the divine. In ancient Egypt, the goddess Nut stretched across the heavens, her body forming the endless night sky, swallowing the sun each evening and birthing it again each dawn in Greece. Philosophers began to wonder if the stars were not gods at all, but perhaps burning stones or distant worlds. To them, the universe was an eternal stage, a cosmosan ordered whole, too vast to comprehend. Some believed the sky was a crystal sphere surrounding the earth, studded with stars like jewels. Others believed it was without boundary, limitless, eternal. And so, even then, two possibilities emerged. Either the universe has an edge, or it stretches into infinity. Can you imagine lying on the ground thousands of years ago, staring upward? With no knowledge of science, no telescopes, no satellites, only your eyes, your breath, and the endless night. What would you feel? Awe, yes, but also fear. For if the heavens never end, then where are we within them? If they do end, then what lies beyond the edge? Infinity is not just a concept, it is an experience. It is the moment your eyes lose themselves in the stars and your mind begins to drift where your body cannot follow. Ancient humanity did not solve the question of infinity. They lived it, they dreamed it, they told stories about it. And in doing so, they carried the first flickers of the cosmic questions that still burn within us today. Asterix, the stars have always been our oldest teachers. Long before telescopes, long before the language of science, people across the world gazed upward and built stories to explain what they saw. Each civilization shaped infinity in its own image, weaving myths that still echo through time. In Mesopotamia, one of humanity's earliest cradles of civilization, the night sky was seen as a divine canvas. The Babylonians mapped the heavens meticulously, believing that the stars carried messages from their gods. To them, infinity was not empty, space was alive with intention. Every celestial motion was a sign. The rising of Venus foretold war or peace. The position of Jupiter revealed the will of the heavens. For them, the universe was a cosmic tablet on which the gods wrote their secrets, and to read the stars was to glimpse eternity itself. In India, ancient thinkers developed some of the most profound ideas about the endless cosmos. Hindu philosophy speaks of Kalpa's vast cycles of creation and destruction, where the universe is born, dies, and is reborn across spans of time so long that they dwarf the human imagination. To them, infinity was not just space, but also time, an eternal rhythm of expansion and dissolution. The stars above were not merely distant fires. They were reflections of an endless process, a cosmic breath inhaling and exhaling forever. Far to the east, China looked upward and saw a harmony of patterns. The sky was not chaos, it was order. The heavens moved in cycles, just like the seasons, just like life. To the ancient Chinese, infinity was the endless balance of yin and yang, the eternal dance of opposites that gave rise to the cosmos. There, astronomers mapped the stars into precise constellations. Their philosophers saw the universe as a vast but ordered flow. Infinity, to them, was not frightening, what was natural. It was the great balance that stretched without end. Across the ocean, Maya civilization raised their temples high into the skies of Central America. They believed the universe was a great layered structure, with multiple heavens stacked above the earth and underworlds beneath it. To them, time itself was infinite, measured in cycles that turned like gears within the heavens. Their calendars reflected not a linear path, but an eternal wheel forever turning. Infinity was not distance, it was recurrence. A return that never ends. And then, in the Greek world, philosophy dared to challenge myth. Thinkers like Anaximander asked, if the universe has edges, what lies beyond them? To him, the cosmos could not be bounded. There had to be something beyond. He called it the apeiron, the boundless, the infinite, the source of all things. Later, Aristotle argued instead for a finite universe, perfectly spherical, encased by celestial spheres. Already, the great debate had begun. Is reality endless? Or does it stop somewhere? Notice how each culture, though separated by oceans and mountains, felt the same pull of infinity. Some saw it as divine cycles, others as harmony, others as a boundless unknown. But none dismissed it. Infinity was always present, pressing against the human imagination like the night sky pressing against the horizon. Now pause for a moment. Imagine yourself walking among these ancient people. You sit by the fire as a Babylonian priest traces constellations in the sky. You hear the chanting of Vedic hymns describing cosmic cycles lasting longer than the age of the earth. You watch. Chinese astronomers carve star charts into stone. You stand at a Mayan temple as the priests align their rituals with the turning heavens. And you listen to a Greek philosopher ask the first great questions of infinity. Do you feel the connection? Across continents and centuries, humanity has always shared this same experience. The awe of looking up at something larger than ourselves, something that does not end. The first encounter with infinity was not through numbers or telescopes, it was through wonder, through stories, through the silence of a star-filled sky. Infinity was not just above them. It was within them. It became part of their myths, their religions, their calendars, their very sense of existence. And in every story, every ritual, every philosophy, one truth remained constant: infinity could not be ignored. It demanded attention. It demanded imagination. And so, the human journey into the infinite continued, guided by myths that tried to explain the unexplainable, myths that gave the unknown a shape, a voice, a rhythm, myths that prepared us for the next step of the moment, when wonder would begin to transform into knowledge. Picture a night thousands of years ago. A child stares at the stars while their parents tell stories about gods and spirits above. That child grows, and one day asks a question that is echoed through history. What if the stars are not gods at all? What if they are something else? That simple curiosity was the seed from which science one day grew. The earliest astronomers were not scientists in the modern sense. They were priests, philosophers, dreamers, observers who recorded the motions of the heavens. They marked the rising and setting of stars, tracked the movement of the moon, noted the repeating cycles of planets. At first, these patterns were used for survival: when to plant, when to harvest, when to prepare for the floods of great rivers. But slowly, something deeper emerged. The patterns hinted at a hidden order, a cosmic design in ancient Mesopotamia. Clay tablets hold records of eclipses and planetary alignments. The Babylonians began to predict celestial events, not by magic, but by calculation. The night sky was no longer just myth. It was becoming mathematics. In Egypt, the stars guided the building of pyramids and temples, perfectly aligned with solstices and constellations. Priests began to understand that the heavens followed precise rhythms. The cosmos was not chaos. It was order. In India, thinkers of the Vedic tradition began asking not just what the universe was, but why it existed. They imagined the cosmos as infinite in both time and scope, far beyond the reach of human comprehension. Infinity was not something distant. It was the very fabric of reality. In Greece, the birth of philosophy gave rise to the first true cosmological models. Thales of Miletus suggested that the universe had a natural origin, not a divine one. Anaximander spoke of the apeiron, the boundless, the infinite source from which everything arises. This was a radical step. Infinity was no longer just a myth. It was a principle of nature, yet others resisted the idea. Aristotle believed infinity was impossible in the physical world. To him, the cosmos was finite, enclosed by crystalline spheres, eternal but bounded. His vision dominated Western thought for centuries, shaping how humanity understood the heavens. And still, the question lingered: was Aristotle right, or did the universe truly extend without end? Infinity became more than a story. It became a paradox. How can something have no edge? How can time stretch without a beginning? How can space expand forever? These were not just philosophical puzzles, they were existential ones. For if the universe has no edge, then where are we within it? If it does, then what lies beyond? Think of those early stargazers. They did not have telescopes. They had no satellites, no equations of relativity, no quantum theory. Yet they carried the same wonder, the same hunger for answers that drives us today. They stood at the threshold of infinity with nothing but their eyes and their imagination. And still, they dared to ask. Their questions were like sparks. Each one lit the path for future generations. From myth to observation, from observation to philosophy, from philosophy to science, the journey toward infinity had begun, and even in those early steps, something remarkable was happening. Humanity was learning to hold two truths at once. That infinity is terrifying, and that infinity is beautiful. It can overwhelm the mind, and yet it can also inspire it. It can make us feel small, and yet it can remind us that we are part of something immeasurably vast. Pause here for a moment. Close your eyes. Imagine standing in an open field under the ancient sky. The air is cool, the world is silent. Above you, countless stars shimmer. You do not know what they are. You do not know how far they reach. You only know that they are there, and they seem endless. That feeling you hold, that quiet awe, the same feeling that carried humanity from myth to science, from wonder to knowledge. Infinity does not belong only to philosophers or scientists. It belongs to all of us. It begins in a simple gaze upward. It begins in the quiet of the night, and it has been with us since the first humans lifted their eyes to the heavens. Thus ends the first chapter of our journey. Humanity's first encounter with infinity was not a discovery. It was an awakening. The stars called to us, and we answered. With stories, with questions, with dreams. And though millennia have passed, we are still answering. We are still dreaming. We are still asking the same questions. Infinity waits. And we continue to follow. Long before telescopes, satellites, or complex theories, humans gazed at the stars and felt a mixture of awe and curiosity. That curiosity, primitive, raw, and insistent, was the first step toward what we now call science. It was the same spark that led a Babylonian priest to record the motion of Venus, an Egyptian scribe to align a pyramid with Orion, and a Greek thinker to ask what lies beyond what we see. Observation is the first tool of science. Ancient civilizations may not have called it that, but they practiced it. They noted patterns, predicted movements, and sought regularities in the apparent chaos of the cosmos. By observing the sky night after night, season after season, they built mental maps that allowed them to navigate both time and space. In Mesopotamia, priests became astronomers. They created star catalogs, predicting lunar and solar eclipses with remarkable accuracy. They noticed that certain stars rose at precise times, marking the seasons and guiding agriculture. The Babylonians understood that the cosmos was governed by patterns, not random whims. Each observation was a step toward quantifying the universe, toward bringing the infinite into human comprehension. Meanwhile, in Egypt, temple architecture revealed a similar principle. Temples and pyramids were aligned with celestial events, not merely for ritual, but because the Egyptians understood the underlying order of the heavens. Their measurements, often painstakingly precise, suggest that they were thinking systematically about space, distance, and time. The cosmos was no longer purely myth, it had structure, and that structure could be studied in Greece. Philosophy became the lens through which observation turned into theory. Thales, Anaximander, and later Pythagoras sought natural explanations for celestial phenomena. They asked, why do the stars move? Why does the moon change shape? Can we understand the universe through reason, not just myth? This was revolutionary. The cosmos was no longer solely a realm of gods. It was a system, a field of study, a horizon that humans could explore intellectually. The Greeks introduced the first scientific principles. Anaximander spoke of the apeiron, the boundless source from which everything arises. Pythagoras and his followers saw numbers and ratios as fundamental to the universe. Geometry was not merely a tool for measuring land, it became a key to understanding the cosmos. The sky, with all its apparent irregularity, could be described mathematically, opening the door to predictions and insights that went far beyond myth. Observation, measurement, and reason were the birthmarks of a scientific horizon. Humanity was beginning to realize that the universe could be understood in systematic ways, even if full comprehension remained beyond reach. The first telescopes would not appear for thousands of years, yet the principle was already there. Look carefully. Record precisely. Think critically. This stage in human thought also reveals the slow blending of imagination and logic. Without imagination, the first ideas of infinity and cosmic order would never have arisen. Without logic, imagination alone could not lead to practical insight. The Babylonians, Egyptians, and Greeks combined both. They imagined the heavens as ordered, predictable, and meaningful, and then began testing that order against observation. Even the concept of the infinite began to shift. Where myth had pictured endless realms inhabited by gods, philosophers, and mathematicians began to formalize infinity in abstract ways. They asked, can space extend without end? Can numbers grow indefinitely? Can the cycles of time stretch beyond human memory? These were questions not of fear, but of curiosity, questions that would form the foundation of scientific thought. As humans continued to observe, measure, and theorize, a new horizon emerged. The understanding that nature followed laws. The night sky was no longer merely a backdrop of wonder. It became a laboratory. Movements of planets, phases of the moon, patterns of eclipses, all could be studied, predicted, and understood. Yet with every answer came new questions. What is light? What is matter? What governs motion on the largest scales? The infinite universe, once a poetic idea, became a practical puzzle. Observation alone was not enough. Hypotheses, experimentation, and eventually mathematics were required to extend the human horizon. Further than the eye could see, this is the essence of the scientific horizon. It begins where wonder meets method. It is a threshold where human curiosity refuses to remain passive. It is the point at which we take the first steps from storytelling to modeling, from myth to understanding. The journey is gradual, patient, and cumulative. Each generation builds on the discoveries of the previous, slowly unfolding a map of the cosmos. As we reflect on this transition from myth to observation, from awe to analysis, it is important to remember the context. Humans were still limited in technology, knowledge, and reach, yet the principles were in place. Curiosity, careful observation, pattern recognition, and critical thinking. These early scientific habits created a horizon that was not physical, but conceptual, a boundary of the known, beyond which lay mystery, ready to be explored by future minds. As humanity's eyes reached higher into the night sky, so too did their minds reach deeper into abstraction. Observation alone was not sufficient to grasp the vastness of the cosmos. Patterns had to be quantified, distances measured, and celestial motions predicted with precision. This is where mathematics, the language of the universe, came into its own. Ancient cultures discovered that numbers could describe more than earthly objects. They could describe the heavens. The Babylonians recorded the movements of planets in numerical tables, calculating positions, months, even years in advance. This was not merely for practical purposes, such as agriculture or religious observances. It was an early recognition that the universe operated according to rules that could be expressed in symbols, ratios, and relationships. In Greece, the connection between numbers and cosmic order deepened. Pythagoras and his followers believed that mathematics was not just a tool, but the foundation of reality itself. They observed that harmonious ratios in music reflected harmonious patterns in the cosmos. Planets, stars, and the moon could be described using numbers, and these numbers revealed an underlying order that transcended mere observation. Mathematics became a bridge from the tangible to the conceptual, a way to extend human perception beyond the limitations of the senses. By the time of Aristarchus of Samos, human thought had begun to consider not only the patterns of the stars, but the scale of the cosmos itself. Aristarchus proposed a heliocentric model, placing the Sun at the center of the known universe, with the Earth revolving around it. Though largely ignored in his time, this idea represented a monumental shift. The universe was not only ordered, but it was vast, perhaps far larger than the human eye could perceive. Measurement, when combined with reason, opened doors that had once seemed locked by myth. Similarly, Hipparchus, the father of trigonometry, developed techniques to measure the positions and motions of celestial bodies with remarkable precision. He calculated the length of the year, mapped hundreds of stars, and even discovered the precession of the equinoxes. Through these methods, the cosmos became more than a canvas of light, became a measurable, predictable system. With mathematics, humanity began to push the boundaries of its horizon. The development of geometry played a particularly crucial role. Euclid's Elements, written around 300 BCE, codified the principles of space, form, and proportion. Geometry allowed humans to calculate distances to distant objects, estimate sizes of celestial bodies, and model the heavens with a rigor that observation alone could never provide. Numbers and shapes became tools to chart the unknown, to extend understanding into regions where human senses could not reach. But even as these tools developed, the concept of infinity continued to challenge thinkers. Numbers themselves seemed to extend without limit. Could the universe behave in a similar way? Could space itself be infinite, just as the counting of numbers could theoretically continue forever? These questions were no longer purely philosophical. They had a mathematical resonance. Infinity became both an abstract idea and a practical consideration in the calculations of astronomers. With the invention of the astrolabe, later the development of more sophisticated instruments, the ability to measure celestial distances improved dramatically. Human hands and minds, guided by mathematical principles, could now quantify what once seemed immeasurable. Apparent motions of planets, the phases of the moon, and the positions of stars could all be charted. Measurement extended the scientific horizon, allowing humans to imagine the universe not just as a sky filled with points of light, but as a structured, dynamic system governed by principles waiting to be discovered. The expansion of knowledge was not linear. It unfolded in fits and starts, leaps and pauses. Ideas that seemed intuitive could be ignored or suppressed, while radical new theories were often dismissed until evidence forced their acceptance. Yet each step, each discovery, nudged humanity closer to an understanding of the cosmos as a vast eos, interconnected whole. Measurement and mathematics became the scaffolding that allowed imagination to climb higher, stretching the horizon ever outward. This was also a period when human thought began to consider scale in ways previously unimaginable. Not only were stars counted and mapped, but the relative sizes and distances of celestial objects were estimated. Aristarchus's heliocentric vision suggested that the Sun dwarfed the Earth. Observers began to realize that planets were worlds, not lights attached to the sky. The universe was expanding in human consciousness. Even if the physical sky remained unchanged, the interplay of mathematics and measurement gave rise to a new kind of certainty. Before, humans relied on myth, intuition, or repeated observation alone. Now, numbers offered predictability. The heavens could be charted, cycles calculated, eclipses predicted. Patterns that once seemed arbitrary revealed themselves as consistent and lawful. This was the birth of the scientific horizon, the understanding that curiosity, when combined with method, could illuminate regions of reality that had once been invisible. At the same time, these advancements brought humility. Every calculation hinted at how small the Earth was compared to the vastness of the cosmos. Every mapped star reminded observers that countless others remained beyond their reach. The scientific horizon was both empowering and humbling, extending human understanding while revealing the enormity of what remained unknown by the time Claudius Ptolemy codified the geocentric system in the Almagest. Centuries of observation, calculation, and theory had already created a framework in which celestial prediction became possible. Even if the model was later proven incorrect, the process mattered. The combination of careful measurement, mathematical reasoning, and systematic observation had become the defining feature of the scientific approach. The horizon had shifted. Humans could now chart, predict, and model, reaching into space in ways their ancestors could only dream of. It is this shift from passive wonder to active inquiry that defines the birth of the scientific horizon. Curiosity remains, but it is guided by logic. Imagination persists, but it is tested against observation. Infinity, once a poetic idea, becomes a measurable challenge, and humans, for the first time, realize that the cosmos is not a static backdrop, but a system of patterns waiting to be understood. And yet, as vast as the universe seemed to these early thinkers, their work laid the foundation for discoveries that would eventually reveal scales beyond comprehension, galaxies, expanding space, and cosmic horizons that dwarf human perception. Every measurement, every calculation, every numerical insight was a step forward, a small leap toward understanding infinity itself. The scientific horizon was born in these centuries, the recognition that the universe, no matter how vast, could be approached with reason, measurement, and mathematics, that the infinite could be explored even if never fully grasped, that human curiosity, disciplined and methodical, could reach beyond the boundaries of myth and imagination to glimpse the underlying order of existence. As the centuries passed, human observation became increasingly systematic, precise, and expansive. The simple act of gazing at the night sky evolved into a rigorous scientific practice, connecting imagination with quantification, curiosity with method. This evolution marks the final stage of what we can call the birth of the scientific horizon, the point at which humans no longer simply wonder at the stars, but seek to understand them, to model the cosmos, and to extend knowledge into realms previously considered beyond reach. During the Renaissance, thinkers such as Copernicus, Galileo, and Kepler revolutionized our understanding of the heavens. Copernicus, reviving Aristarchus's heliocentric model, proposed that the sun, not the earth, was at the center of the cosmos. This was more than a new arrangement of planets. It was a paradigm shift in human thought. The horizon of knowledge had expanded. The Earth was no longer the cosmic center, and humanity's perspective had to accommodate a universe far larger and more complex than previously imagined. Galileo, through his telescope, brought the heavens closer to human perception. Suddenly, moons orbited Jupiter, mountains and craters marked the moon, and the Milky Way revealed itself as a river of countless stars. Observation and measurement combined to challenge long-held assumptions and to reveal the true scale of the cosmos. The scientific horizon widened as humans began to understand that space was not a uniform dome, but a layered, structured, and dynamic expanse. Kepler added mathematical rigor, deriving precise laws for planetary motion. No longer was the cosmos a realm of approximation or poetic speculation. It became a system that could be described, predicted, and understood through numbers and geometry. The birth of modern astronomy was inseparable from the interplay of observation, mathematics, and imagination, a triad that continues to define scientific inquiry today. As human tools and methods improved, so did our understanding of cosmic scale. The invention of more powerful telescopes, spectroscopes, and later radio telescopes allowed observation beyond visible light. Humanity began to detect phenomena invisible to the naked eye: distant galaxies, nebulas, and the faint glow of the cosmic microwave background. The scientific horizon stretched not only in distance but also in dimension, encompassing forms of energy and matter that were once inconceivable. The understanding of the universe's expansion, first hinted at by Edwin Hubble in the 20th century, further transformed the scientific horizon. Hubble's observations of galaxies moving away from each other suggested that space itself was stretching, that the cosmos had a beginning, the Big Bang, and that its evolution could be traced through time. Suddenly, the universe was no longer static. It was dynamic, expanding, and vast beyond previous imagination. Measurement, prediction, and theory intertwined to reveal a cosmos that was simultaneously tangible and awe-inspiring. This modern understanding rests on the foundation laid by centuries of curiosity, observation, and abstraction. The early Babylonians, Egyptians, and Greeks provided the first glimpses of patterns and order. Renaissance thinkers formalized these patterns, linking observation with mathematical law. By the 20th century, humanity could not only observe the universe, but also understand its evolution. From the earliest moments after the Big Bang to the formation of galaxies, stars, and planets. And yet, the scientific horizon continues to expand. Each answer generates new questions. What is dark matter, and why does it dominate the universe? What is dark energy, and how does it drive cosmic acceleration? Are there other universes beyond our own, or is our cosmos truly all there is? The boundaries of knowledge are always provisional, extending further with each generation's insight. In this sense, the scientific horizon is not a fixed point. It is a moving frontier, continually pushed outward by inquiry, imagination, and discovery. The birth of this horizon is also a story about human perspective. Early civilizations measured the stars in ways suited to their time and technology. Renaissance thinkers refined these methods with telescopes and mathematics. Modern astronomers now use satellites, particle detectors, and computational simulations to probe regions of space and time far beyond human senses. Each advancement is a step along the horizon, revealing new dimensions and scales that previous generations could not even conceive. Perhaps the most profound lesson from this evolution is humility. The universe is immense, complex, and often counterintuitive. Early humans imagined gods controlling the sky. Renaissance scientists discovered a mechanistic order. Modern cosmology reveals a universe governed by subtle, elegant laws, yet still filled with mysteries. The horizon is vast, and humans are small, but curiosity, combined with method, allows us to reach further than we ever thought possible. The process of reaching this horizon is also deeply reflective. Observing the cosmos forces us to confront questions of scale, existence, and significance. Are we alone? What is our place in an ever-expanding universe? Does the cosmos have an edge, or is it infinite? These questions, which began with myth and speculation, have evolved into measurable, modelable inquiries. And even as science answers some, it leaves room for wonder, ensuring that the horizon remains dynamic and inspiring. The birth of the scientific horizon, therefore, is not simply a historical milestone. It is a continuing journey. Each generation builds upon the previous, extending the boundary of the known and embracing the unknown. Ancient observations, mathematical formalism, Renaissance innovation, and modern cosmology form a continuum, a lineage of curiosity and intellect. And through it all, the human mind persists in seeking, measuring, imagining, and marveling. Finally, the horizon teaches patience and persistence. The universe does not reveal its secrets instantly. Discovery is cumulative, slow, and often painstaking. Yet with every observation recorded, every equation solved, every theory tested, humanity moves further along this horizon. And in this movement, we find both the satisfaction of knowledge and the inspiration of endless mystery, a duality that has defined the scientific pursuit from the earliest stargazers to modern cosmologists scanning the cosmic microwave background for clues about the origin of everything in the quiet of the night. As we reflect on these advances, one truth becomes clear. The birth of the scientific horizon is both an external and internal journey. It is the expansion of human knowledge outward into space, and simultaneously the expansion of human imagination inward into the depths of understanding, reason, and curiosity. The universe is vast, but so too is the human capacity to explore. Mind, observation, and mathematics all combined to push the boundary of the known ever further, laying the foundation for generations yet to come. And as you lie in calm reflection, perhaps drifting towards sleep, consider this. The horizon is always just beyond reach, not a limit, but a guiding line. Every star, every pattern, every cosmic law is a step along the horizon. Each observation from the Babylonians to Hubble brings us closer to understanding, yet reminds us that infinity, mystery, and wonder remain always inviting, always beckoning, forever stretching outward into the silent, majestic expanse of the cosmos. As we shift our gaze from the birth of scientific observation to the limits of what can be seen, a new horizon emerges, the cosmic horizon. This is not a physical wall or boundary, but the ultimate limit of perception, conceptual line marking, the furthest reaches of the observable universe. It is where light, traveling for billions of years, finally reaches our instruments, bringing with it whispers of the universe's earliest moments. Imagine standing on a beach, looking out across the endless ocean. The horizon appears as a line where sky meets water, a boundary that seems definite, yet is an illusion created by perspective. Similarly, the cosmic horizon is a limit defined not by the universe itself, but by the speed of light and the age of the cosmos. The universe may extend infinitely beyond it, yet we can only observe what has had time to reach us since the Big Bang. The cosmic horizon is approximately 46 billion light-years away in every direction. This number is staggering, almost impossible to comprehend. It means that the light we now see from distant galaxies began its journey when Earth itself was not yet formed. Each photon carries a story across eons, revealing the conditions of the early universe. By observing them, astronomers can reconstruct the cosmos's infancy, from the formation of the first atoms to the birth of galaxies. But even as we peer across this vast distance, we confront limits. The horizon is not static. It is continually expanding as the universe grows. Some regions that emitted light billions of years ago are now moving away from us faster than light can travel due to the expansion of space itself. These regions lie forever beyond observational reach. The universe, in a sense, contains parts that are eternally inaccessible, lying outside our observational bubble. Beyond the cosmic horizon, the concept of the horizon also challenges human intuition. We are accustomed to thinking of distance and size in terms we can easily grasp: meters, kilometers, or even light-years within the Milky Way. But when confronted with the cosmic scale, intuition fails. Distances become so vast that light-years, billions of them, feel abstract. Time stretches into epochs we can scarcely imagine. And yet, measurement allows us to translate these unfathomable scales into a language we can understand, to measure the universe. Astronomers rely on light across the electromagnetic spectrum. Visible light is only a small portion. Infrared, ultraviolet, X-ray, and radio waves reveal structures invisible to our eyes. Each wavelength provides clues about different cosmic phenomena: star formation, galactic collisions, and the cosmic microwave background, the afterglow of the Big Bang itself. Observing these signals is akin to listening to the universe's whispers, each one carrying information from a distant past. The cosmic horizon is also a reminder of the universe's age. At 13.8 billion years, the universe is young in cosmic terms. Even though light from some galaxies has traveled for nearly that long, the universe's expansion stretches the distance. making the observable universe larger than one might initially assume. In essence, the horizon represents a snapshot of the universe as it was, not as it is. What we see is history itself, unfolding across unimaginable scales, beyond the technical details. There is a poetic element to the horizon. It represents both our reach and our limitation. We can see farther than any ancient observer ever could, yet we remain confined by fundamental physical laws. The horizon is a boundary of knowledge shaped by time, space, and the speed of light. It humbles us, reminding us that, for all our technological advancement, some regions of the cosmos will remain forever beyond our grasp. Even within the horizon, mysteries abound. Galaxies, billions of light-years away, appear as faint smudges. Yet each contains billions of stars, each star potentially hosting countless planets. Clusters of galaxies trace invisible threads of dark matter, shaping the universe's large-scale structure. The cosmic web, mapped through careful observation, shows a tapestry far more intricate than the human mind can easily picture. Our instruments reveal patterns, yet the full complexity remains elusive. Teasing us with glimpses of infinity, understanding the cosmic horizon also reframes human perspective. The night sky, once a personal and immediate experience, now stretches into the vast scale of the observable universe. Stars that appear close may lie millions of light-years apart. The Milky Way itself is but one of billions of galaxies. Standing beneath the night sky, one may feel small, yet connected to a grander reality defined by laws, patterns, and structures that transcend human lifespan and comprehension. The horizon invites contemplation not only of space, but also of time. Light from distant galaxies shows us the universe's history. Galaxies in infancy, stars just forming, and the gradual assembly of cosmic structures. Observing these ancient signals is akin to looking backward in time. Each photon carries a narrative from billions of years ago, allowing humans to reconstruct the universe's story, piece by piece. Finally, the cosmic horizon challenges the very notion of an edge. There is no wall, no boundary to touch. Beyond the horizon, the universe continues, perhaps infinitely. What we call the horizon is merely the limit of what we can see, constrained by the finite speed of light and the age of the cosmos. This distinction is crucial. The universe may be boundless, yet our knowledge is limited. The horizon is both a marker of progress and a reminder of mystery. In this way, the cosmic horizon embodies the dual nature of scientific exploration. It is at once the culmination of centuries of observation, mathematics, and theory, and a doorway to questions that have no definitive answers. Infinity lies beyond, but within the horizon, humans have mapped, measured, and understood more than any previous generation could dream. As we lie beneath the stars, contemplating this vast boundary, we are invited to dream, to imagine, and to continue the journey. The cosmic horizon is not merely a scientific concept. TEA is a symbol of human curiosity, of the persistent drive to explore and understand, even in the face of limits. And in the quiet, in the stillness of night, it whispers. To us, there is always more to see, more to know, more to imagine. As we continue our journey toward the farthest reaches of the universe, we confront the inherent limitations of observation. The cosmic horizon is not merely a distant point. It is a dynamic boundary defined by the finite speed of light, the age of the cosmos, and the expansion of space itself. Beyond this horizon lies the unknown, a realm we may never see, a silent expanse that exists beyond the reach of even our most sophisticated instruments. Consider the universe as a vast ocean, with a horizon marking the furthest waves our eyes can discern. Yet the ocean stretches endlessly beyond what we can perceive. Similarly, Regions of space beyond the cosmic horizon are moving away from us faster than light can traverse the expanding cosmos. No photon from these regions will ever reach Earth, making them forever inaccessible. We can theorize about them, model them mathematically, but they remain beyond direct observation, cloaked in the mystery of the infinite. Even within the observable universe, the light we see carries the weight of time. When we look at a galaxy billions of light years away, we are seeing it as it was billions of years ago. Its present state, possibly dramatically altered by cosmic evolution, remains hidden. This interplay between distance, time, and observation underscores the profound challenge of comprehending the cosmos. Our knowledge is always partial, limited by the very laws of physics that govern the universe. The cosmic horizon also forces us to reconsider what it means to see. Observation is not passive. It is an active reconstruction of reality. Light from distant galaxies is faint, often distorted, stretched, or absorbed by intervening matter. Telescopes and detectors capture these signals, which are then processed, corrected, and interpreted. What we see is already a translation, a careful decoding of ancient photons carrying information across vast stretches of space and time. The horizon, in this sense, is not a fixed line, but a complex interplay of physics, instrumentation, and human perception. One of the most profound insights comes from the cosmic microwave background, CMB. The afterglow of the Big Bang. The CMB represents the earliest light that could escape the dense, opaque plasma of the infant universe. Observing it is akin to peering back nearly 13.8 billion years, capturing the universe in its infancy. Yet even the CMB marks a limit. Before that, time, the universe, was opaque. No light traveled freely. The horizon of the observable universe is therefore defined not only by distance, but by the very physics of light itself. Beyond the cosmic microwave background lies speculation. Cosmologists consider the possibility of regions beyond our horizon, containing galaxies, stars, and structures similar to those we can see, or perhaps entirely different forms of matter and energy. These regions may follow the same laws of physics, or may diverge in ways we cannot yet imagine. Mathematical models suggest that the universe could be far larger than the observable portion, potentially infinite. Yet, infinity, by its nature, eludes complete comprehension and direct observation. The concept of unobservable regions challenges both intuition and imagination. We are accustomed to thinking of the universe as a finite, reachable space where every point can, in principle, be explored. Yet the cosmic horizon reminds us that the universe contains regions fundamentally beyond our reach. No matter how advanced technology becomes, the expansion of space ensures that some galaxies, stars, and structures will remain eternally hidden. This creates a fascinating duality. The universe is knowable in part, yet infinite in potential. The horizon also has implications for the fate of light itself. As space expands, light from distant galaxies is redshifted, stretched to longer and longer wavelengths. Eventually, this light becomes undetectable, merging into the background noise of the cosmos. Galaxies that are now observable may one day vanish beyond our observational reach, leaving future civilizations to wonder what once existed. The horizon, therefore, is not static. It evolves as the universe expands, shaping the limits of knowledge. Across cosmic time, understanding the cosmic horizon requires both imagination and mathematical rigor. Cosmologists use models based on general relativity, the expansion of space, and observational data to infer the properties of regions beyond the observable universe. While direct observation is impossible, the laws of physics allow us to make predictions. In this sense, the horizon is not a barrier, but a challenge, inviting human intellect to extend understanding into realms that cannot be seen, but can be reasoned about. Even within the observable limits, mysteries abound. the large-scale structure of the universe reveals filaments, voids, and clusters formed by dark matter, invisible yet shaping everything we see. The cosmic web hints at patterns that may continue indefinitely beyond the horizon. Each observation, each measurement, is a glimpse into a greater order, a window into structures and processes that extend far beyond the human lifespan or comprehension. Contemplating the horizon, also, deepens philosophical reflection. We are part of a universe vast beyond measure, yet capable of understanding its laws. The observable cosmos is finite, measurable, and increasingly mapped, but it exists within a potentially infinite backdrop. Humanity's quest is both practical and poetic, to measure, predict, and model the universe, while also marveling at the endless expanse that stretches beyond our reach. The cosmic horizon is a testament to human curiosity and persistence. It embodies the limits of observation while simultaneously highlighting the progress of science. From ancient stargazers to modern cosmologists, each generation pushes the boundary outward, expanding the horizon of knowledge. Yet the horizon is never fully reached. It recedes as the universe expands. As light travels and as new mysteries emerge, ultimately, the cosmic horizon reminds us that the universe is a dynamic, ever-changing expanse filled with regions we can see, regions we cannot, and perhaps regions we can only imagine. The limits of observation are not failures, but invitations. Invitations to explore, to reason, and to dream, even as we lie beneath the night sky. Contemplating the farthest points visible through telescopes and satellites, we are participants in a story that stretches across billions of years and trillions of light years, a story of light, time, space, and endless curiosity. In this quiet reflection, one realizes that the cosmic horizon is both a scientific concept and a symbol. It marks the boundary of what we can perceive, the edge of what we know, and yet it also points beyond, toward infinity, mystery, and the enduring human drive to explore. Every observation is a step along this horizon, every photon a messenger from the edge, and every discovery a bridge between the known and the unknowable. As we reach the final segment of our exploration of the cosmic horizon, we turn from technical limits to philosophical reflection, contemplating not only what the horizon is, but what it signifies. The cosmic horizon is more than a line drawn. By physics, it is a window to infinity, a boundary that inspires wonder, humility, and curiosity. By understanding its implications, we glimpse both the vastness of the universe and the depth of human perception. The horizon represents the ultimate interface between the known and the unknown. Within it, every observation, every photon of light, every measurement contributes to a growing tapestry of knowledge. We map galaxies, chart cosmic filaments, and decode the relic radiation from the Big Bang. Yet beyond that boundary, the universe may continue without end, stretching into regions that will never be observed, existing in dimensions both spatial and temporal that elude even our most powerful instruments. In this sense, the horizon embodies the eternal tension between what is accessible and what remains forever mysterious. Consider what it means to gaze across billions of light years, to see a galaxy as it was billions of years ago. Each glance is both a journey and a meditation, connecting observer to the vast cosmos. Light travels across time and space, bringing a record of distant events into our consciousness. The cosmic horizon, therefore, is not just a limit of sight. It is a bridge linking human awareness to the universe's history. We witness the unfolding of cosmic evolution, the formation of stars and galaxies, and the dance of matter across the epochs. Yet the horizon reminds us of impermanence and change. The universe is not static. Galaxies drift, clusters collide, stars are born and die. Regions we now see may eventually move beyond our observational capacity due to cosmic expansion. What is observable today may be invisible tomorrow, and what is beyond the horizon today may forever remain beyond reach. The horizon teaches patience, showing that discovery is both cumulative and fleeting, a gift of time measured on cosmic scales. The horizon also challenges our sense of scale. Human experience is bound by earthly dimensions, lifespans, and perception. But the cosmic horizon expands this frame, introducing scales that dwarf human imagination. Light years, billions of years, and vast intergalactic distances reshape our understanding of place and time. The Earth, our solar system, even the Milky Way, appear minuscule against this backdrop. Yet, within this immensity, human curiosity persists, reaching further with each generation's tools, theories, and insights. Meditating on the cosmic horizon evokes humility and awe. We are small, yet capable of remarkable understanding. Ancient stargazers marveled at the night sky. Modern astronomers decode it with mathematics, instruments, and theory. Both perspectives share the same core: wonder at the vast, seemingly infinite universe. The horizon reminds us that knowledge is provisional, always extending outward, always leaving space for the mysterious and unknown. But the horizon is also hopeful. It suggests that exploration never ends, that each answer uncovers new questions. Even as some regions of the universe remain forever unobservable, the universe within reach grows increasingly rich and detailed. Galaxies, clusters, dark matter, structures, and cosmic microwave signals provide endless material for study and contemplation. The horizon is not a wall. It is an invitation, guiding human curiosity toward ever greater understanding, in a sense. The cosmic horizon is a mirror reflecting human ambition. Just as light reaches us from distant galaxies, human thought reaches across time and space, connecting generations of observers, thinkers, and dreamers. Each measurement, each telescope, each mathematical model extends our reach. The horizon is a shared human endeavor, a collective meditation on what exists beyond immediate perception, and on what might exist in regions forever out of reach. The horizon also raises profound questions about infinity. If the universe continues beyond observation, what does it mean to exist in unobservable space? Are there structures, patterns, or even phenomena fundamentally different from those within the observable cosmos? These questions may never be answered directly, yet they push the boundaries of imagination and theory. The cosmic horizon invites us to consider not only what we can measure, but also what we can conceive in contemplating the cosmic horizon. One can also reflect on the philosophical and emotional dimensions of exploration. The vastness beyond challenges anthropocentric views, reminding us that the universe is not centered on humanity. Yet it is through our observation and understanding that meaning is constructed. The horizon is both a reminder of limitation and a symbol of potential. It demonstrates the finite scope of perception while simultaneously suggesting that knowledge and discovery can stretch infinitely. Finally, the cosmic horizon encourages a meditative appreciation of the universe. As we lie beneath the night sky, contemplating the light of galaxies billions of years distant, we participate in a silent dialogue with the cosmos. Each photon is a messenger, carrying history, structure, and the essence of distant reality into our consciousness. The horizon, far from being a boundary, becomes a window, a portal to imagination, understanding, and the infinite possibilities of existence. It is here, at the edge of perception, that human curiosity thrives. The horizon is a dynamic, living boundary receding as we advance, challenging us to expand our knowledge and our imagination simultaneously. And as the universe continues its silent expansion, it invites us to watch, to learn, and to dream. The cosmic horizon teaches that exploration is unending, that the universe is vast, and that the human mind is capable of reaching toward infinity, even if we can never fully touch it. And so, in the quiet moments beneath the stars, as thoughts drift like photons across time and space, we find a profound truth. The cosmic horizon is not merely a limit. It is an inspiration, a guide, and a testament to the endless journey of understanding, a boundary defined by physics, yet enriched by wonder, imagination, and the eternal human desire to know what lies beyond. As we move deeper into our exploration of the cosmos, we arrive at a question both simple and profound. What is the shape of the universe? Unlike a room or a planet, the universe does not offer visible walls or defined edges. Its geometry is subtle, woven into the very fabric of space and time, revealed only through careful observation and thoughtful interpretation. Understanding this geometry helps us grasp not only the structure of the cosmos, but also the rules by which it evolves and expands. To begin, we must distinguish between local geometry and global geometry. Local geometry describes the curvature of space in a small region, influenced by nearby mass and energy. This curvature is what governs the motion of planets, stars, and light near massive objects. For example, Einstein's theory of general relativity tells us that mass bends space, curving the paths along which light travels. When we observe light bending around a galaxy or a cluster, we witness local geometry in action, space, shaped by the presence of matter. Global geometry, K, on the other hand, refers to the shape of the universe on the largest scales, encompassing the totality of space. Here, the concepts are more abstract. Cosmologists often speak of three possibilities: a flat universe, a closed universe, or an open universe. A flat universe extends infinitely in all directions, its parallel lines never meeting, and the angles of a triangle summing to exactly 180 degrees. A closed universe, by contrast, curves back on itself like a sphere, potentially finite, but without a boundary. An open universe curves like a saddle, extending infinitely, but with negative curvature. Observations suggest that, on large scales, the universe is remarkably flat. Measurements of the cosmic microwave background, gravitational lensing, and the distribution of galaxies all converge on this conclusion. Yet flatness is not synonymous with simplicity. Even in a flat universe, local curvature bends the paths of light. Massive structures form complex webs, and dark energy accelerates expansion. Flatness describes the overall geometric tendency, but the universe remains a dynamic, evolving, and intricate structure. One of the most intriguing consequences of geometry is its effect on the fate of the universe. In a closed universe, expansion might eventually halt, giving way to contraction, a cosmic cycle, sometimes called the Big Crunch. An open universe, by contrast, continues expanding forever, becoming colder, emptier, and darker with time. Our flat universe, combined with the effects of dark energy, seems destined for accelerated expansion, with galaxies moving ever farther apart. The night sky eventually stripped of most distant lights. Geometry, therefore, is not an abstract. Mathematical curiosity dictates the ultimate destiny of the cosmos. The geometry of space is intimately tied to the distribution of matter and energy. Regions of high density curve space more strongly, producing observable phenomena such as gravitational lensing, where light from distant galaxies is warped by intervening mass. By mapping these distortions, astronomers reconstruct the universe's large-scale structure, revealing a cosmic web of filaments and voids. Geometry here is both a tool and a lens, allowing us to decode the universe's architecture and understand the forces shaping it. Another key aspect of cosmic geometry is the interplay between space and time. In Einstein's framework, space-time is a four-dimensional fabric, and geometry describes not only distances in space, but also intervals in time. Mass and energy bend space-time, influencing the motion of planets, the trajectory of light, and the passage of time itself. This four-dimensional perspective transforms our understanding. Geometry is no longer static or purely spatial, it is a living, dynamic property of the cosmos, reacting to the contents of the universe and influencing its evolution. The concept of curvature also leads to profound visualizations. Imagine a beam of light traveling across vast intergalactic distances. In a flat universe, the beam continues straight, preserving angles and proportions. In a closed universe, the beam gradually curves, potentially looping back on itself. In an open universe, the beam diverges, spreading over larger angles. These abstract ideas, while mathematically precise, also carry poetic weight. The shape of space subtly governs the journey of every photon, the path of every galaxy, and the unfolding story of cosmic history. Geometry further informs cosmologists' understanding of the early universe. In the moments following the Big Bang, quantum fluctuations produced tiny variations in density. These variations, amplified by gravitational forces, seeded the formation of galaxies and large-scale structures. The resulting cosmic web reflects the universe's geometric properties, with filaments tracing paths of gravitational influence and voids stretching across millions of light-years. In this way, geometry is both initial condition and ongoing influence, shaping the cosmos from its inception to the present as humans. Contemplating the universe's geometry stretches our imagination. We are accustomed to the familiar Euclidean space of everyday life, where lines are straight, angles are constant, and space appears uniform. Yet the cosmos challenges these intuitions. Space can curve, stretch, and warp. Parallel lines can converge or diverge. Distances and angles depend on mass, energy, and expansion. Understanding geometry on cosmic scales requires abstract reasoning, careful observation, and a willingness to let go of earthbound assumptions. The geometry of the universe also resonates with philosophical reflection. It asks us to consider scale, continuity, and infinity. A closed universe suggests a finite, self-contained cosmos. An open universe hints at endless possibility. A flat universe bridges the two, infinite yet balanced. Each model carries implications not only for astrophysics, but also for our sense of place and perspective. The cosmos, through its shape, teaches humility, wonder, and a profound appreciation for the complexity of existence. Finally, study of cosmic geometry exemplifies the synergy between observation, theory, and imagination. Telescopes measure light, satellites map the cosmic microwave background, and supercomputers simulate the evolution of structure. Geometry ties these threads together, providing a framework to interpret data, test hypotheses, and envision scenarios. Beyond direct observation, 'tis a language both precise and poetic, describing the universe in terms comprehensible to the human mind, yet hinting at realities beyond perception. As we continue to explore the geometry of the universe, the concept of curvature takes center stage. Curvature is the bending of space itself, influenced by mass, energy, and the expansion of the cosmos. On small scales, curvature is subtle, detectable only near massive objects. Light bends around stars and galaxies, producing gravitational lensing, which allows us to observe otherwise hidden cosmic structures. These distortions serve as a window into the invisible dark matter, the scaffolding upon which visible matter is arranged. On larger scales, curvature informs the shape of the universe as a whole. Cosmologists analyze the distribution of galaxies and the cosmic microwave background to determine whether space is flat, positively curved, or negatively curved. Observational evidence suggests a universe that is extremely close to flat, yet tiny deviations may exist, providing clues about early cosmic inflation and the density of the universe. Even small curvature can have profound consequences. subtly affecting the paths of light and the evolution of large-scale structure. The geometry of the universe is intricately linked to its large-scale structure, which resembles a vast cosmic web. Filaments of galaxies stretch across hundreds of millions of light-years, connecting clusters and superclusters in intricate networks. Between these filaments lie immense voids, nearly empty regions that emphasize the vastness and complexity of cosmic architecture. This structure is not random. It is shaped by the initial quantum fluctuations amplified by gravity over billions of years. In this sense, geometry and structure are inseparable, revealing both the rules of physics and the emergent patterns of cosmic evolution. Dark matter plays a central role in shaping this cosmic architecture. Invisible yet dominant in mass, dark matter governs the curvature of space on large scales. Its gravitational influence guides the formation of galaxies, their clustering into filaments, and the creation of voids. Without dark matter, the universe's geometry would look dramatically different, and the patterns we observe in the cosmic web might never have emerged. Observing these structures allows cosmologists to infer the underlying distribution of dark matter, offering a glimpse into the unseen framework of reality. Geometry also influences cosmic expansion. The universe is not a static stage. It grows and evolves. Space itself stretches, causing distant galaxies to recede from us. This expansion is influenced by the density and curvature of the universe, as well as by dark energy, a mysterious force accelerating the growth of space. In a positively curved universe, expansion could eventually slow and reverse. In a negatively curved or flat universe, expansion continues indefinitely. Observing these dynamics helps us understand not only geometry, but also the ultimate fate of the cosmos. The interplay of geometry and light produces some of the most beautiful phenomena in the cosmos. Gravitational lensing, as mentioned earlier, creates arcs and rings of light around massive objects, bending photons along curved paths. These cosmic mirrors allow astronomers to observe galaxies far beyond normal limits, revealing the universe's hidden depths. Each lensing event is a direct illustration of space-time geometry, showing how curvature shapes the journey of light across billions of light-years. Another fascinating aspect is the cosmic microwave background, CMB, the faint afterglow of the Big Bang. Tiny temperature fluctuations in the CMB reflect density variations in the early universe, which in turn influence the large-scale geometry we observe today. Mapping these fluctuations has provided strong evidence for a flat universe. Yet it also offers insights into the primordial conditions that led to cosmic inflation. The CMB is both a snapshot of the universe's infancy and a blueprint for understanding its geometry billions of years later. The curvature of space also affects cosmic distances and how we perceive them. In curved space, the relationship between redshift, distance, and brightness differs from that in flat space. Light from distant objects can be stretched or compressed depending on the curvature, altering our perception of size and separation. Cosmologists must account for these effects when estimating distances, masses, and velocities of galaxies, making geometry a crucial component of precise cosmic measurement. Geometry further informs the understanding of cosmic topology, or the global connectivity of space. Even if space is flat locally, it might possess complex global properties, such as wrapping back on itself in a higher dimensional shape. In such a universe, traveling far enough in one direction could, in principle, return you to your starting point. While this remains theoretical, exploring these possibilities stretches human imagination and underscores the profound connection between geometry and the nature of reality. The study of cosmic geometry also encourages reflection on human perception. We are accustomed to straight lines, right angles, and Euclidean spaces in our daily lives. Yet, the cosmos challenges these intuitions. Space can curve subtly or dramatically. Distances can stretch across unimaginable scales, and the shape of the universe can influence the trajectory of light and matter. By studying geometry on these scales, humans expand the capacity for abstract thought, visualizing dimensions and structures far beyond ordinary experience. Ultimately, the geometry of the universe is both a scientific and philosophical inquiry. It reveals the patterns that govern cosmic evolution, the hidden scaffolding of dark matter, and the dynamic processes shaping galaxies and clusters. At the same time, it invites contemplation of scale, infinity, and our place within the cosmos. The universe's shape, its curvature, and its structure are not only measurable phenomena, but also profound sources of wonder, inspiring both rigorous study and meditative reflection. The cosmic web, gravitational lensing, and the CMB are all pieces of a larger puzzle. Geometry provides the framework in which these pieces fit together, guiding our understanding of how the universe began, how it has evolved, and how it may continue to unfold. It transforms abstract mathematics into a tangible narrative of creation, structure, and cosmic interconnection. In this way, geometry serves as a bridge between the observable and the theoretical, between measurement and imagination. It allows humans to translate faint signals into meaningful maps, to comprehend patterns across billions of light years, and to glimpse the deep order underlying apparent chaos. The shape of the universe is more than science. It is a testament to curiosity, intellect, and the enduring human desire to understand the cosmos in all its grandeur. As we enter the final part of our journey through the geometry of the universe, we find ourselves contemplating the grandest scale of all, the interplay between cosmic shape and the infinite horizon. The geometry of space is not confined to the galaxies, clusters, or filaments we can observe. It extends beyond the cosmic horizon, intertwining with concepts of infinity, expansion, and the potential limits of human understanding. The universe's geometry informs not only what we can see, but also what may exist beyond observation. If space is flat, it may stretch infinitely, allowing structures and galaxies to extend endlessly beyond our perception. If closed, it may loop upon itself, forming a finite but unbounded cosmos. Either way, the geometry of the universe shapes our horizon, dictating the ultimate reach of light, matter, and information. In essence, geometry provides the scaffolding upon which the universe unfolds, visible and invisible alike. One of the most profound consequences of geometry is its effect on the cosmic horizon itself. The horizon is defined by the finite speed of light and the expansion of space. In a curved or expanding universe, the horizon becomes dynamic, shifting outward as light travels across the cosmos, yet receding as distant regions accelerate beyond the speed of light relative to us. Geometry determines how quickly this horizon expands, how distant objects appear, and the pathways along which light travels. It is geometry that connects the observable universe with the vast unknown lying beyond. Consider, it's a vast network of galaxies in the cosmic web. Geometry shapes their distribution, creating filaments, voids, and clusters. These structures stretch across billions of light years, their arrangement guided by curvature and gravitational forces. But beyond the horizon, the pattern may continue indefinitely, or it may take forms entirely unfamiliar to us. By studying geometric patterns within our observable slice of the cosmos, we can infer the potential architecture of the unobservable regions, extending understanding into the infinite through reason and imagination. The interplay of geometry and cosmic expansion also affects how we perceive time and distance. Light from distant galaxies travels across curved space, its journey stretched and redshifted by the expanding universe. The farther an object is, the more its light is altered by geometric effects and expansion. This not only shapes our observations, but also the way we reconstruct cosmic history. Every measurement becomes a journey through space, time, and curvature, connecting human perception to events billions of years past. Geometry also raises questions about the nature of infinity. An infinite, flat universe challenges comprehension. Can infinity truly exist, or is it merely a mathematical abstraction? If space is unbounded, does every possible arrangement of matter eventually occur somewhere? These questions touch both physics and philosophy, blurring the line between measurable reality and speculative thought. The cosmic horizon and geometry together highlight the limits of observation, yet also the boundless potential of imagination. The curvature of space may also influence the ultimate fate of the universe. In a closed, positively curved cosmos, expansion might slow, reverse, and culminate in a big crunch, recycling matter and energy in an eternal cycle. In a flat or negatively curved universe, expansion continues indefinitely, galaxies drifting ever farther apart, the night sky eventually darkening as starlight fades. Geometry dictates not only form, but destiny, intertwining shape and time in a cosmic narrative spanning billions of years. Meditating on cosmic geometry encourages reflection on human perception and understanding. On Earth, our senses are adapted to finite scales, familiar shapes, and Euclidean intuition. Yet the universe challenges these notions. Lines can curve, space can stretch, and parallel paths may never meet or may loop infinitely. Grappling with these realities expands not only scientific knowledge, but cognitive and imaginative capacities. Geometry teaches humility, reminding us that the universe operates on scales, both spatial and temporal, far beyond ordinary experience. The cosmic horizon, combined with geometric principles, also emphasizes the dynamic, evolving nature of reality. As the universe expands, regions once visible may recede beyond reach, and new areas may come into view. Geometry governs this evolution, dictating the paths along which light and matter travel, shaping the apparent structure of the cosmos. Over time, the horizon and geometry together create a living, breathing universe, vast, intricate, and continually unfolding. Furthermore, cosmic geometry highlights the interconnectedness of all things. Local curvature around galaxies and clusters, large-scale flatness across billions of light-years, and the potential infinite stretch beyond the horizon all form a unified fabric. Each photon traveling through space, each galaxy moving along gravitational paths, each void separating filaments, is part of an elegant, interconnected structure. Geometry is the language of this structure, revealing patterns, relationships, and the profound harmony underlying cosmic chaos. Ultimately, contemplating the universe's geometry invites a meditative perspective. Lying beneath the stars, we realize that every visible galaxy is a small piece of a vast, possibly infinite cosmos. Geometry connects the familiar with the unknown, the observable with the unobservable, and the finite human mind with the infinite cosmos. The curvature, structure, and shape of the universe become more than scientific concepts. They are gateways to wonder, reflection, and awe. In this reflective state, one can appreciate the poetic resonance of cosmic geometry. Curvature bends not only light, but imagination. Horizons stretch not only across space, but across thought. Filaments and voids reveal the intricate beauty of patterns unfolding over billions of years. The universe, through its geometric fabric, whispers stories of formation, evolution, and possibility, inviting observers to participate in an endless exploration of both knowledge and mystery. Geometry, as we now understand, is both the map and the territory. It describes how space behaves, how light travels, and how matter assembles. Yet it also opens the mind to the infinite, suggesting that what lies beyond observation may be as rich, complex, and beautiful as the universe we can see. The cosmic horizon, the large-scale web, and the curvature of space-time together form a symphony of structure and potential. A universe whose elegance is reflected in both its mathematics and its vast silent poetry. Thus, as we conclude this chapter, we can view the geometry of the universe as a bridge connecting human curiosity to cosmic infinity, linking measurable phenomena to the mysterious and uniting observation with imagination. It reminds us that the universe is both knowable and unknowable, structured yet infinite, and that in seeking to understand its shape, we participate in a timeless dialogue with the cosmos itself. As we step into the vast realm of infinity, we confront a concept that defies ordinary experience, challenging both mind and imagination. Infinity is not merely very large. It is a fundamental idea that stretches the boundaries of mathematics, physics, and human cognition, from the abstract symbols on a page to the immeasurable expanse of the cosmos. Infinity permeates every layer of understanding, inviting contemplation, awe, and sometimes bewilderment. In mathematics, infinity has been rigorously explored, first conceptually and later with formal precision. One of the most revolutionary figures in this endeavor was Georg Cantor, who developed set theory and the concept of different sizes or cardinalities of infinity. Cantor showed that not all infinities are equal. The infinity of natural numbers is smaller than the infinity of real numbers, which is uncountable. This insight fundamentally altered our understanding of mathematics, revealing a hierarchy within the infinite itself. Cantor's work led to the idea that one could compare infinities in a meaningful way. The natural numbers 1, 2, 3, and so on form a countably infinite set. Yet the real numbers between 0 and 1 form an uncountably infinite set, so vast that it cannot be matched one-to-one with natural numbers. The mind struggles with this concept. How can one infinity be larger than another? Yet mathematics demonstrates with absolute clarity that these distinctions are real and logically consistent, even if they remain counterintuitive. Another influential mathematician, David Hilbert, approached infinity from a different perspective, particularly through his famous paradoxes and his work on infinite dimensional spaces. Hilbert imagined a hotel with an infinite number of rooms, all occupied, yet still able to accommodate new guests by rearranging occupants. Known as Hilbert's Hotel, this thought experiment illustrates the strange properties of infinity, where conventiona, logic fails, and intuition must yield to formal reasoning. Through this paradox, Hilbert showed that infinity is not a mere abstraction, it has concrete, if peculiar, implications. These mathematical explorations provide a foundation for understanding physical and cosmological infinity. Yet the transition from abstract mathematics to tangible reality raises new questions. Does the universe itself embody these forms of infinity? Can space, time, or matter be truly infinite? While mathematics allows us to manipulate and compare infinite sets, the physical world confronts limits of observation, causality, and measurement. Nevertheless, the insights of Cantor and Hilbert illuminate the paths by which human thought can approach these profound mysteries. Mathematical infinity also intersects with cosmology and the structure of the universe. Consider the possibility of an infinite cosmos. If space extends without bound, then, in principle, every possible arrangement of matter could exist somewhere. This leads to striking implications. Infinitely many stars, galaxies, and perhaps even infinitely many variations of Earth. The infinite becomes not merely a number, but a landscape of possibility. A canvas upon which the laws of physics play out in endlessly diverse ways. Human cognition, however, struggles to grasp infinity. We are creatures of finitude. Our senses perceive limited distances. Our lifespans are brief, and our minds naturally conceptualize the world in discrete, bounded units. When confronted with the idea of endlessness, the brain hesitates, recoils, or attempts to impose finite frameworks on infinite realities. Cantor and Hilbert provide the tools to navigate this tension, offering formal structures in which infinity can be handled logically. Yet the emotional and philosophical response remains profound and disorienting. Even in everyday mathematics, infinity appears in surprising ways. Fractions, limits, and series converge or diverge, hinting at unending processes within finite expressions. Calculus formalizes these ideas, showing how infinitesimal steps accumulate into finite results, or how infinite series can sum to exact numbers. Infinity is simultaneously an abstract concept, a practical tool, and a philosophical challenge. It bridges the calculable and the incomprehensible, guiding human thought beyond ordinary experience. In this context, we can reflect on the relationship between mathematical infinity and physical reality. While numbers can be unbounded, physical measurements may not extend indefinitely. The observable universe has limits. Distances, durations, and energies are finite for any given observation. Yet the principles of mathematics allow us to imagine realities beyond these bounds, hinting at possibilities that physics may one day confront or approximate. Infinity, in this sense, becomes a bridge between theory and imagination, a guide for exploring questions that stretch beyond empirical reach. Infinity also invites us to consider patterns and repetition in the cosmos. If space is infinite, then structures, galaxies, clusters, and even planetary systems may recur endlessly. The statistical likelihood of duplication becomes non-zero, leading to speculative but mathematically grounded scenarios. Infinitely many stars like our Sun, planets like Earth, and perhaps even sentient beings with arrangements of matter similar to our own. Mathematics provides a framework to conceptualize such possibilities, translating abstract infinity into tangible implications for the cosmos. Ultimately, the first part of our exploration of infinity establishes a foundation for understanding its broader implications. From Cantor's transfinite numbers to Hilbert's paradoxes, mathematical infinity offers both precision and wonder. It equips us to explore physical infinity, to imagine the vastness of the cosmos, and to consider the potential for structures and realities beyond the observable universe. Yet it also confronts human perception with its limits, challenging intuition and inviting humility in the face of boundlessness. In this quiet reflection, one realizes that infinity is not merely a concept, but an experience, an intellectual and emotional journey into the limitless, a meditation on the immeasurable, and a reminder that human thought can reach far beyond ordinary perception. It is a domain where logic and imagination intertwine, where mathematics becomes a bridge to the infinite, and where the universe itself may mirror the strange, beautiful, and paradoxical properties discovered by the pioneers of thought. Having explored infinity through the lens of mathematics, we now turn to its manifestation in the physical universe. Unlike the abstract infinities of Cantor and Hilbert, physical infinity engages our senses and imagination in a more tangible, yet no less mind-bending way. It is found in the seemingly endless stretch of space, the boundless count of stars, and the speculative realms of parallel or duplicate universes. From our vantage point on Earth, the night sky seems finite, dotted with countless stars. Yet even a casual glance cannot capture the true scale. Observations suggest that there are over 100 billion galaxies in the observable universe, each containing hundreds of billions of stars. The sheer number of stellar bodies stretches the mind, hinting at a universe so vast that our familiar scales of comprehension fall away. Here, the infinity of mathematics begins to find a mirror in physical reality, though we cannot observe every star. The numbers approach the unimaginable, brushing against the edges of infinite thought. Yet the universe may extend far beyond what we can see. The observable universe is limited by the speed of light and the age of the cosmos, about 13.8 billion years. Beyond this horizon lies unobservable space, which may stretch indefinitely. If the cosmos is indeed infinite, then the total number of stars, galaxies, and clusters could be limitless. In this sense, physical infinity is not merely a philosophical abstraction, but a real possibility. Shaping the context in which all cosmic events unfold, the concept of infinite repetition arises naturally from this scenario. In a spatially infinite universe with a finite number of particle configurations, some arrangements of matter may repeat. This leads to a remarkable implication. There could exist other regions of space that are nearly identical to our own, hosting stars, planets, and perhaps even conscious beings arranged in patterns mirroring those on Earth. Such possibilities, though speculative, are grounded in statistical reasoning and the principles of physics, linking the idea of infinity to tangible cosmic scenarios. Cosmologists often frame this as the doppelganger universe hypothesis. If the universe is infinite, then every possible configuration of particles occurs somewhere. Somewhere, far beyond our observational reach, there could be a planet, indistinguishable from Earth, inhabited by beings similar to ourselves. The notion challenges the imagination, compelling us to confront both the vastness of space and the limits of what we can perceive. Infinity, in this sense, transforms the universe from a backdrop into a realm of boundless possibilities, where reality itself may repeat infinitely. The concept of physical infinity also touches on cosmic expansion and the role of dark energy. As space stretches, galaxies recede from one another, some eventually disappearing beyond our horizon. While the universe may be infinite, the observable portion remains finite and ever-changing. Geometry and expansion combine to create a dynamic picture, a universe that is vast, possibly infinite, yet experienced through the lens of a moving horizon. Even infinity, in physical terms, is framed by the relative limitations of observation. Stars and galaxies themselves hint at the paradoxical nature of infinity. While the numbers are immense, each star is finite, each galaxy measurable. Yet, when combined, these finite elements contribute to a sense of boundless scale. Light from distant stars, traveling for billions of years, connects us to events in a universe that may extend forever. Each observation is a dialogue with infinity, a bridge linking finite perception with limitless space. Physical infinity also raises questions about cosmological duplication and probability. In an infinite universe, even extraordinarily rare events occur infinitely many times. A star identical to our Sun, a planet like Earth, or even a copy of our solar system could exist somewhere beyond reach. This reasoning applies not only to matter, but potentially to life and consciousness, while the distances involved are unimaginably. Vast mathematics assures us that the odds of repetition are non-zero, and in infinity, repetition becomes inevitable. The challenges of conceptualizing this scale are profound. Human cognition evolved to navigate finite spaces and lifespans. Grappling with an infinite number of stars or the potential for duplicate universes stretches imagination to its limits. Our senses are accustomed to boundaries, and our minds are attuned to discrete scales. Infinity, whether mathematical or physical, defies these intuitions, demanding abstraction, reflection, and humility. Moreover, the infinity of the cosmos invites reflection on cosmic perspective. Each star, galaxy, and cluster is a single part of an enormous, possibly infinite structure. Observing the universe becomes an exercise in mental expansion, imagining distances far beyond the familiar, considering the existence of countless unseen worlds, and contemplating a universe in which our own experiences are but one small configuration among countless others. Infinity is simultaneously a scientific and philosophical horizon, framing human understanding in the context of vast cosmic scales. The intersection of physical infinity and cosmology also highlights the role of probability and statistical reasoning. While exact duplication of Earth or our solar system is staggeringly unlikely within a finite volume, infinity makes the improbable inevitable. Physics and mathematics provide a scaffold for reasoning about these outcomes, linking abstract concepts to plausible cosmic scenarios. Thus, physical infinity becomes both a measure of scale and a guide for speculation, allowing science to imagine possibilities that extend far beyond empirical verification. Finally, it's contemplating the infinite distribution of stars, galaxies, and potential duplicate universes encourages both awe and meditation. Infinity is no longer merely a number or symbol. It becomes an experience, an intellectual and emotional journey into the vastness that surrounds us. The mind wanders among uncountable stars, across infinite cosmic voids, and through the conceptual corridors of possible realities, appreciating the depth, scale, and beauty of a universe that may extend without end. As we reach the final part of our exploration of infinity, we turn inward, toward the human mind and its struggle to grasp the unbounded. Infinity, whether mathematical or physical, challenges cognition at its deepest levels. It is a concept that resists the limitations of perception, defies ordinary experience, and stretches the imagination beyond familiar scales. To truly appreciate the infinite, one must navigate both intellect and intuition, learning to dwell in a state of contemplation and wonder. Human cognition evolved to manage finite environments, spaces with boundaries, objects with limits, and durations measured in days and years. Our brains excel at recognizing patterns, estimating quantities, and planning for future outcomes, all within finite parameters. Yet infinity defies these instincts. It is not a large number or an extensive quantity. It is an unending process, a boundless continuum that transcends measurement and comprehension. To conceptualize infinity requires the suspension of everyday reasoning and the embrace of abstract thought. One challenge lies in visualizing the infinite. The mind instinctively seeks closure, edges, and limits. Infinity has none. To imagine an infinite set of numbers, an endless expanse of space, or a limitless sequence of events, we must rely on symbols, analogies, and mental exercises. Cantor's transfinite numbers and Hilbert's paradoxical hotel provide intellectual scaffolding. Yet even with these tools, the experience remains partially elusive. Infinity stretches cognition to its furthest reaches, demanding humility and patience. The psychological impact of infinity is profound. Encounters with the infinite can evoke feelings of awe, wonder, and sometimes vertigo. The human mind senses both the beauty and the disorienting nature of unboundedness. Contemplating an endless universe, infinite stars, or countless possible worlds can inspire meditation, philosophical reflection, and existential inquiry. Yet it can also provoke discomfort, as familiar frameworks of understanding no longer suffice. In this tension lies the paradoxical allure of infinity, simultaneously intimidating and transcendent. Language itself struggles to describe infinity. Words rely on boundaries and definitions, yet infinity transcends finite categories. Philosophers and mathematicians have long grappled with the limitations of expression. Metaphors, analogies, and symbolic representation become essential tools, enabling humans to communicate and reason about the ungraspable. Even so, the experience of infinity remains partly ineffable, a domain where thought and imagination intersect but never fully converge. The brain's temporal limitations also constrain comprehension. While numbers, distances, and probabilities can be calculated incrementally, infinity implies an unending progression. No matter how long we think, calculate, or observe, the infinite extends beyond any finite period of cognition. This temporal mismatch amplifies the difficulty of grasping infinity, It is simultaneously present in thought and forever beyond the reach of complete understanding. Meditative engagement with infinity offers one pathway to harmony with the concept. By approaching infinity slowly and deliberately, the mind can learn to dwell in its vastness without fear or confusion. Visualization exercises, contemplative reasoning, and reflection on abstract patterns can create a sense of immersion, allowing the intellect to engage with the infinite while the consciousness remains centered. In this state, infinity is no longer purely a challenge, it becomes an expansive, almost spiritual landscape for thought. Physical and mathematical infinities intersect with philosophical inquiry in this process. The mind contemplates not just numbers or stars, but the implications of infinite possibility. If the universe extends without limit, what does this mean for life, meaning, and identity? If events repeat or configurations recur, what are the consequences for perception and experience? Infinity forces a reconsideration of scale, causality, and significance, expanding both the mental and existential horizon. One particularly intriguing aspect is the recursive nature of infinity in thought itself. Considering infinity often leads to nested reflections, infinite sequences of numbers, endless repetition of cosmic events, and recursive possibilities in parallel realities. The mind becomes a mirror for infinity, reflecting its properties and struggling to contain them. In this sense, contemplating infinity is as much a psychological exercise as a scientific or philosophical one, highlighting the interplay between cognition and cosmic scale. Despite its challenges, the human mind demonstrates remarkable capacity for engaging with infinity. Through mathematics, physics, and philosophy, we can reason about infinite sets, unobservable regions of space, and countless potential universes. These intellectual tools provide structure and clarity, translating the incomprehensible into patterns, probabilities, and theoretical models. Yet at the same time, infinity retains its wonder, reminding us that no model or equation can fully capture the boundless. Meditation on infinity, also, invites emotional and aesthetic responses. There is a subtle serenity in imagining an unbounded cosmos, a calmness that arises from contemplating the scale and continuity of existence. Like watching waves stretch endlessly toward the horizon, or gazing into a night sky that seems without end. Infinity can inspire a quiet reflection, a sense of connection to something far greater than oneself. It is in this meditative engagement that infinity becomes accessible not as a finite object of study, but as an experiential reality of contemplation. The human struggle with infinity reflects a deeper truth. Our minds are finite, yet capable of approaching the boundless. Through structured reasoning, symbolic thought, and meditative reflection, we can engage with concepts that exceed everyday comprehension. We can imagine universes without end, sequences of numbers without limit, and repetitions of reality in patterns beyond observation. Infinity, in this way, becomes both a scientific challenge and a philosophical adventure, a bridge between intellect and imagination. Finally, as we bring this chapter to a close, consider infinity not as a problem to solve, but as a horizon to explore. Whether through mathematics, physics, or contemplation, infinity invites patience, curiosity, and wonder. It encourages us to dwell in the vastness, to imagine beyond perception, and to appreciate the scale and beauty of existence. The mind may never fully grasp infinity, yet the act of trying illuminates both the cosmos and our place within it, revealing the profound interplay of thought, space, and endless possibility. As we step beyond the boundaries of what can be seen, we enter a domain where observation fades and speculation begins. The observable universe, defined by the distance light has traveled since the Big Bang, forms a spherical bubble around us, stretching roughly 46 billion light-years in every direction. Yet beyond this cosmic horizon, the nature of space remains hidden. What exists beyond the observable universe? Can there be a beyond at all? Or is our cosmic bubble all that there is to experience? Cosmologists have long grappled with these questions, using both theory and inference to explore possibilities. One scenario is that the universe continues in much the same pattern as what we can observe. If space is homogeneous on sufficiently large scales, then beyond the cosmic horizon lies more galaxies, clusters, and structures extending indefinitely. In this view, the universe is infinite in extent, and the horizon represents not a limit to existence, but a limit to perception. Infinity appears again, now in a tangible cosmic form, challenging us to imagine a space far larger than what our instruments can ever reveal. Yet the universe might also be finite, but unbounded. A subtle and counterintuitive idea that challenges everyday reasoning. In this scenario, space curves back on itself in a higher dimensional sense, like the surface of a sphere, which is finite in area, yet has no edge. The universe could be limited in total volume, while still allowing uninterrupted travel in any direction. Move far enough in one direction, and you could theoretically return to your starting point, never encountering a boundary, but always progressing within a finite yet continuous space. This notion evokes both wonder and profound conceptual difficulty. The universe is bounded, yet has no edge. One useful way to visualize this is through the balloon analogy, a classic tool in cosmology. Imagine a two-dimensional creature living on the surface of a balloon. To this being, the surface appears endless locally, but as the balloon inflates, every point moves away from every other point. There are no edges, yet the surface is finite. Now extend this analogy to three-dimensional space. Our universe might be like the balloon's surface, embedded in a higher dimensional space, expanding over time, with every galaxy receding from every other galaxy. The cosmic horizon, then, is a local limitation of perception, not a wall at the end of space. The concept of a cosmic horizon plays a central role in understanding what lies beyond. The horizon is determined by the finite speed of light and the finite age of the universe. Any information from beyond this horizon cannot yet reach us, and perhaps never will if expansion accelerates indefinitely. As we peer toward the limits of the observable universe, we realize that the horizon is dynamic. Galaxies that are visible today may drift beyond detection tomorrow, their light forever outpaced by the stretching of space itself. Infinity and limitation intersect here, creating a landscape where observation is always partial, and speculation becomes a necessary companion to knowledge beyond the horizon. Cosmologists entertain a variety of speculative possibilities. Could there be regions with different physical constants where matter behaves in unfamiliar ways? Could there be structures beyond comprehension, shaped by forces or dimensions unknown to our experience? Some theories, such as those inspired by inflationary cosmology, suggest that what we see is only one pocket within a vast multiverse, with other regions separated by immense expanses of inflating space. In such scenarios, the universe is more than just vast. It is fragmented into countless domains, each potentially with its own laws and histories, even within the framework of a finite but unbounded universe. The concept of beyond becomes nuanced. There is no edge, no wall, and no termination of space. Yet there is a practical horizon set by the limits of observation and light travel. This distinction highlights the subtlety required when thinking about cosmic boundaries. To the naked eye or any conceivable instrument, there is a limit. Yet space may extend indefinitely or loop back upon itself in higher dimensions. Our perception of infinity, then, is always mediated by light, time, and geometry. Speculating about what lies beyond the observable universe also invites reflection on cosmic structure at extreme scales. If the universe is homogeneous and isotropic, on large scales, Then, beyond the horizon, lie more of what we see: galaxies, clusters, filaments, and voids. Yet, if inhomogeneities exist at extreme distances, new patterns may emerge, challenging our understanding of structure, formation, matter, distribution, and the fundamental laws of physics. The unknown beyond the horizon is a frontier not of emptiness, but of potential richness, waiting to be imagined through the lens of theory and the guidance of mathematics. Finally, contemplating the universes beyond encourages a meditative tave, awareness of scale and perspective. The observable universe, immense though it seems, may be a tiny island within a far greater cosmic ocean. The balloon analogy and the notion of finite but unbounded space invite reflection. While our perception is limited, the universe itself may be seamless, continuous, and endlessly unfolding. Infinity, curvature, and expansion converge, offering a vision of space that is both scientifically grounded and philosophically profound, a realm where imagination and observation intertwine. In this first part of the chapter, we have laid the groundwork for considering the universe beyond observation, its possible infinitude, its potential finitude without edges, and the ways geometry and expansion shape our understanding. We have begun to explore the delicate boundary between what can be known and what can only be imagined, setting the stage for a deeper journey into the nature of the cosmic beyond. As we continue our journey beyond the familiar boundaries of observation, the notion of a cosmological horizon takes center stage. The horizon is not a physical barrier, but a limit imposed by the finite speed of light and the finite age of the universe. What lies beyond this horizon is fundamentally speculative, yet physics and cosmology provide frameworks to reason about these regions, revealing possibilities that stretch the imagination and challenge intuition. One compelling framework comes from inflationary cosmology. According to inflation theory, in the first fractions of a second after the Big Bang, space expanded exponentially, creating vast regions far larger than the observable universe. If inflation occurred as theorized, then beyond our horizon lies an unimaginably enormous expanse of space, perhaps with domains that differ slightly or dramatically in structure and physical constants. These pocket universes form part of a multiverse scenario where each region follows the same laws of physics but develops independently, creating an intricate and potentially infinite cosmic tapestry. To visualize this, the balloon analogy proves invaluable. Imagine the universe as the surface of a balloon being slowly inflated. Galaxies are represented by points on the balloon's surface. As the balloon expands, each point moves away from every other point. Importantly, the surface has no edge. There is no center on the two-dimensional surface itself. This two-dimensional analogy maps onto our three-dimensional space. The universe may expand into higher dimensions, with every region receding from all others, yet without a boundary or edge. The cosmological horizon is then analogous to the distance a creature on the balloon can see, limited not by edges, but by the finite speed of signals traveling across the surface. The balloon analogy also illuminates the concept of a finite yet unbounded universe. Though the balloon's surface is finite, it has no edge. One can travel indefinitely without encountering a boundary, extending this to three-dimensional space. Our universe may be topologically similar, with finite volume but infinite continuity in motion. This possibility challenges the intuitive notion of outside the universe. There may be no beyond in a conventional sense, only unending space that curves back upon itself in higher dimensional geometry beyond the horizon. Speculative structures could exist, varying from the familiar to the extreme. Perhaps there are vast voids with no galaxies, regions dominated by dark matter, or zones where the density and arrangement of matter differs significantly from our local environment. Theoretical models even allow for regions with slightly different laws of physics where forces behave differently, particle masses vary, or fundamental constants diverge. These possibilities, while speculative, arise naturally from inflationary theory and the statistical variation inherent in an extended cosmos. Cosmic expansion plays a crucial role in shaping what lies beyond perception as the universe expands. Distant galaxies recede from us at speeds approaching or exceeding the speed of light relative to our local frame. This expansion stretches space itself, pushing regions beyond our cosmological horizon. Light emitted today from those regions may never reach us, rendering them permanently unobservable. In this sense, the beyond is not a fixed location, but a dynamic frontier, continually moving outward as space stretches and horizons evolve. The interplay between geometry, expansion, and observation leads to fascinating consequences. For instance, the cosmic microwave background (CMB) offers a glimpse into conditions just 380,000 years after the Big Bang, a snapshot of the universe at its earliest observable stage. Yet even the CMB marks the limit of visibility. Beyond it, photons have not traveled far enough for detection. Speculating further, regions beyond the horizon may contain the seeds of new structures, patterns of matter and energy entirely disconnected from our observational frame. The universe, in this sense, is layered, a visible interior surrounded by a vast and unknowable exterior. The philosophical implications of a horizon and its beyond are profound. If our observable universe is but a small bubble in an immense or infinite cosmos, then the center of all things is not local but diffuse. Every observer, in principle, has their own horizon, creating a multiplicity of vantage points. This leads to a relational view of space. The universe is defined not by absolute boundaries, but by the network of observable regions, each expanding and receding in a complex, interwoven structure. Infinity is manifest not only in space, but in perspective, with each observer experiencing a unique slice of the cosmos. Considering these perspectives, we confront the subtle question, what does beyond mean if there is no outside? In a finite but unbounded universe, outside may be a meaningless concept. The universe has no edge, no boundary, and no external space into which it expands. Rather, space itself stretches, curves, and connects, forming a continuum. The balloon analogy makes this tangible. An ant walking on the surface never reaches an edge, and any notion of outside the surface is undefined within the two-dimensional plane. Similarly, our three-dimensional universe may be self-contained, expanding internally without a surrounding void. Speculation about the universe's beyond also invites consideration of multiverse hypotheses. If inflation produces numerous disconnected regions, each evolving independently, then the universe as a whole may be far grander than the observable portion. These regions could vary in density, structure, or even physical laws, forming a mosaic of realities beyond comprehension. In such a framework, our observable universe is a single bubble within a sea of potentially infinite bubbles, each with its own history, geometry, and evolution. Ultimately, contemplating the universe beyond observation requires both imagination and caution. Scientific reasoning guides us through probabilities, geometries, and models, yet the true nature of the beyond may remain forever hidden. The cosmological horizon marks the boundary of knowledge, while speculation opens a realm of possibility. Infinity, curvature, and expansion converge, creating a cosmic landscape that is simultaneously rigorous and mysterious. Measurable in principle, yet limitless in imagination. As we reach the final part of our journey into the beyond of the universe, we confront one of the most subtle and profound concepts in cosmology: the possibility that the universe is finite, yet unbounded. This idea challenges our intuitive understanding of space and edges. suggesting that while the universe may contain a finite amount of space, it has no borders, no walls, and no termination point. It stretches the mind, inviting contemplation of a reality in which motion is unending. Yet the total volume remains limited. The balloon analogy, introduced in the previous part, offers a vivid way to imagine this. Consider the two-dimensional surface of a balloon, finite in total area, yet without any edge. A creature walking along the surface could travel indefinitely, never encountering a boundary. Similarly, our three-dimensional universe may curve back upon itself in higher dimensional space, creating a finite but unbounded topology. In this sense, there is no outside to the universe. Space itself is the continuum, expanding internally, stretching the limits of perception without encountering an edge. This conception has profound implications for the cosmological horizon. While we perceive a limit to what we can observe, determined by the distance light has traveled since the Big Bang, this horizon is not a physical barrier. Beyond it lies a continuation of space, perhaps similar to what we see locally, perhaps dramatically different, but always extending the tapestry of reality. Light from these distant regions has simply not reached us, and in some cases may never reach us if the expansion of space continues to accelerate. Here, the universe blends finitude with infinity, bounded in total volume, yet effectively infinite in experience from any given observational point. One of the most intriguing aspects of a finite yet unbounded universe is how it reshapes our concept of beyond. In everyday life, we associate beyond with a spatial extension past a border. Yet if space curves back on itself, the notion of an outside becomes meaningless. There is no surrounding void into which the universe expands. The expansion is intrinsic, occurring within the very fabric of space itself. Every direction, every trajectory, eventually loops back in a higher dimensional sense. In contemplating this, we are invited to expand our intuition and embrace a form of spatial thinking that defies ordinary perception. The mathematical frameworks underlying these ideas come from the study of geometry and topology in cosmology. Einstein's general theory of relativity allows for a variety of spatial curvatures: positive, negative, or flat. A positively curved universe, for example, can be finite and unbounded, similar to a three-dimensional analog of a sphere. In such a universe, the sum of angles in a triangle exceeds 180 degrees and parallel lines eventually converge. These geometrical properties are not abstract curiosities, they govern the behavior of light, the motion of galaxies, and the structure of cosmic horizons. Speculating further, the finite yet unbounded nature of the universe offers fascinating implications for repetition and cosmic patterns. If space curves back on itself, a photon traveling long enough might eventually return to its starting point. Galaxies, stars, and even regions of space could be replicated in distant loops, producing echoes of structures at cosmic scales. This notion complements earlier discussions on infinite repetitions in an infinite universe. But now framed in a finite context, unboundedness allows endless motion and exploration without requiring an infinite volume. The interplay between expansion, curvature, and horizon generates a rich tapestry of possibilities. Space itself is dynamic, stretching over time with distances between galaxies increasing. Even in a finite universe, expansion gives rise to phenomena that mimic infinity from an observational standpoint. Galaxies recede beyond visibility, light from distant regions fades, and new cosmic horizons emerge. The universe feels limitless to an observer. Yet it may remain finite in total contenta. Paradox both intellectually challenging and profoundly beautiful. Reflecting on these ideas invites a meditative perspective. Imagine drifting through a universe that curves back on itself, where the journey never encounters a wall. Yet all points are interconnected in a seamless continuum. Every motion, every trajectory is part of a self-contained fabric. yet the expanse feels boundless. Infinity is felt not as a number, but as an experience of space, of time, of continuity stretching beyond ordinary comprehension, the mind accustomed. To edges and limits is invited to expand and float in this cosmic panorama, contemplating a finite yet unbounded universe also. Touches on existential and philosophical reflections. Our place in such a universe is both central and infinitesimal. Every observer occupies a local bubble, yet is part of a larger, self-contained whole. The cosmic horizon reminds us of our limits, while the curvature and expansion hint at unbounded exploration. Space and time blend into an elegant continuum, where edges are illusions and boundaries are conceptual rather than physical. Encourages humility, wonder, and a profound sense of connection to the cosmos. The balloon analogy, when extended to meditation, becomes a tool for intellectual and emotional engagement. Picture yourself as a point on the balloon's surface, gliding over the curvature of space. Galaxies recede and approach. The horizon shifts, and the universe expands around you. You feel the tension between finitude and unboundedness, the interplay of limitation and endlessness, and the serene beauty of a cosmos without edge, yet rich with structure. Such visualization cultivates both understanding and a sense of cosmic awe. Finally, as we close this chapter, consider the universe's beyond as a space of possibility rather than limitation. Whether the universe is infinite, finite, yet unbounded, or part of a multiverse, the act of contemplating it expands our perception, stretches our imagination, and nurtures wonder. The horizon, the curvature, and the expansion are not just scientific phenomena, they are gateways to reflection, a canvas for meditation, and a bridge between intellect and intuition. The universe's beyond, whether real or conceptual, invites us to journey mentally, emotionally, and spiritually, exploring infinity, without fear and embracing the boundless mystery of existence. As we venture further into the mysteries of existence, we encounter the tantalizing notion of a multiverse, the idea that our universe might be only one of many, possibly infinite, realities. This concept challenges our perception of uniqueness, causality, and even personal identity. In contemplating multiverses, we must navigate quantum mechanics, cosmology, and speculative physics, exploring scenarios that stretch imagination while remaining grounded in theoretical frameworks. One of the earliest and most intriguing approaches to multiverses comes from quantum mechanics. The quantum world is governed by probabilities. Particles exist in superpositions representing multiple potential states simultaneously. According to the many worlds interpretation, each quantum event does not merely resolve into a single outcome. Instead, all possible outcomes occur, each in its own branching universe. When a particle is measured, the universe splits, creating parallel realities where every conceivable outcome is realized. In this sense, every decision, fluctuation, and event spawns an enormous tree of alternative histories, forming a vast quantum multiverse. The implications of quantum multiverses are staggering. In one branch, a coin flip results in heads. In another, tails. In one universe, a galaxy forms in a particular configuration. In another, it does not. Every possibility permitted by the laws of physics manifests somewhere. This leads to profound philosophical and existential questions. Is there a version of you in another universe living a completely different life? Are all conceivable histories, successes and failures instantiated somewhere in the quantum multiverse? While these questions may seem abstract, they highlight the tension between human intuition and the staggering richness of quantum reality. Beyond quantum mechanics, cosmic inflation offers another path to multiverses. Inflation theory proposes that the universe underwent a period of rapid exponential expansion in the first fractions of a second after the Big Bang. This inflationary phase smoothed out irregularities, producing the homogeneous and isotropic universe we observe today. Yet inflation also suggests the possibility of eternal inflation, in which different regions of space stop inflating at different times. Some areas form bubble universes, each with its own distinct properties, constants, and histories. These bubbles float in an inflating cosmic sea, generating a multiverse of infinite possibilities. The bubble multiverse, or pocket universe concept, presents a fascinating scenario. Each bubble emerges as a separate universe, potentially, with different physical constants, forces, or structures. Some may resemble our own universe closely. Others might diverge dramatically with unfamiliar particles, laws, or dimensions. In this framework, the observable universe is merely one bubble within a boundless ensemble. The cosmic horizon we experience is local, limited to our bubble. While the multiverse extends indefinitely beyond perception, the interplay between quantum branching and inflationary bubbles suggests a layered multiverse. Quantum events create branching realities within each bubble, while eternal inflation generates new bubbles with varying physical properties. Together, these mechanisms hint at a cosmos of unimaginable richness, where every potential history and configuration exists somewhere. The vastness of this concept is difficult to comprehend, requiring both abstract reasoning and a meditative approach to thought. As the mind attempts to scale beyond familiar dimensions of space, time, causality, the notion of multiverses also dovetails with cosmic probability and randomness. In a sufficiently vast or infinite multiverse, every arrangement of matter, every pattern of stars, and every combination of events may occur somewhere. This implies that even extraordinarily improbable events, life emerging in multiple ways, planets forming identical to Earth, or histories mirroring our own could exist. The universe we observe, then, is not the only way reality can manifest. It is simply the one we inhabit, with countless alternatives unfolding elsewhere, while inflationary and quantum multiverses are grounded in physics. They remain speculative in nature. Direct observation of other universes may be impossible, as each bubble or branch could be causally disconnected from our own. Yet indirect evidence, such as patterns in the cosmic microwave background, the structure of space-time, or theoretical consistency, offers a foundation for reasoning. The pursuit of multiverse theories is as much a conceptual exploration as an empirical one. Bridging imagination, mathematics, and philosophy, contemplating multiverses also introduces deep existential questions. If infinite or vast numbers of universes exist, where does individuality reside? Does it make sense to ask whether another version of me lives elsewhere? In quantum terms, every possible version of you exists in some branch. In inflationary multiverses, entire regions of reality may mirror or diverge from your experiences. This realization can evoke awe, humility, or existential vertigo, as the familiar sense of self is reframed within a vast and branching cosmic context. Finally, the concept of multiverses invites a meditative engagement with scale and possibility. Imagine drifting among countless bubble universes, each a cosmos in its own right, or visualizing the branching of realities from every quantum decision. The mind is both challenged and expanded, learning to inhabit a landscape where space, time, and outcomes multiply beyond comprehension. In this meditative visualization, the multiverse is not just an abstract theory. It becomes an experiential space, allowing the imagination to roam freely among the infinite possibilities of existence. In this first part of the chapter, we have explored the foundations of multiverse theories, the quantum branching of possibilities, the cosmic inflationary generation of bubble universes, and the philosophical questions these ideas raise. We have begun to appreciate the richness and complexity of a cosmos that may extend far beyond our local experience, hinting at realities where every imaginable outcome and every alternate self exists. As we delve deeper into the idea of multiple universes, the framework of string theory emerges as a fascinating avenue for exploration. String theory proposes that the fundamental constituents of reality are not point particles, but tiny, vibrating strings whose different modes of vibration give rise to the particles and forces we observe. This seemingly abstract notion has profound implications. It naturally requires additional spatial dimensions beyond the familiar three that are compactified, hidden from our perception yet shaping the fabric of reality. These extra dimensions open the door to parallel universes in a very literal sense. If strings vibrate differently in different dimensions, or if different regions of these hidden dimensions evolve uniquely, then distinct universes could emerge with alternative physical laws. In some versions of string theory, the universe we inhabit is a three-dimensional brain floating in a higher dimensional space or bulk. Other brains might exist in this bulk, each representing a separate universe with its own stars, galaxies, and perhaps entirely different chemistry and physics. The multiverse, in this view, is a higher dimensional landscape in which our universe is only one of many brains coexisting in a vast cosmic arena. The concept of brains introduces another layer of possibility: brain collisions. In certain models, universes might interact through these higher dimensional spaces. A collision between brains could, in principle, generate energy and matter, potentially even producing a new universe or altering the properties of an existing one. While this remains speculative, it provides a theoretical bridge connecting string theory, cosmology, and the multiverse concept. Here, the universe is not isolated, but embedded in a dynamic, multidimensional structure with interactions and consequences that are, for now, largely beyond direct observation. Parallel universes, as envisioned through string theory and extra dimensions, also resonate with the idea of multiple versions of ourselves. In a universe with infinite or near-infinite configurations, every possible arrangement of matter, including conscious beings, may exist somewhere. This leads to the intriguing, almost poetic question: is there a version of me living in another universe, making different choices, following alternative paths? Quantum multiverse theories and string-theoretic landscapes converge here, suggesting that while such counterparts may exist in principle, they remain causally disconnected from us, forever out of reach, yet present in the broader cosmic tapestry. The landscape of string theory itself is mind-boggling in scale. There may be on the order of 10,500 possible vacuum states, distinct configurations of strings, brains, and compactified dimensions. Each state corresponds to a different universe with its own constants, particle content, and laws. This multitude offers a compelling explanation for fine-tuning our universe. Hospitable to life may simply be one among an astronomically vast ensemble, where some universes naturally allow stars, planets, and chemistry to emerge. Life, consciousness, and our particular cosmic conditions become a statistical inevitability in the grand multiverse. Extra dimensions also invite imaginative visualizations, while we perceive three spatial dimensions. Additional dimensions may be compactified into scales far smaller than an atomic nucleus. In these hidden dimensions, alternative physical phenomena could occur, influencing the observable universe subtly through fundamental constants or force strengths. The multiverse could, therefore, consist not only of separate brains but also of variations encoded within these compact dimensions, each producing universes that differ in ways that are subtle, profound, or utterly alien. Another perspective arises from parallel universes in cosmology. If the universe is infinite or extremely vast, every arrangement of matter could occur somewhere, even in a finite but sufficiently large universe. Statistical reasoning implies that regions identical to our observable patch, even slightly altered variants exist. These parallel realities might be astronomically far away, beyond any conceivable horizon, yet theoretically present as part of the same cosmic continuum. Here, parallel universes are not born from higher dimensions, but emerge naturally from the probabilistic behavior of matter and energy in a vast cosmos. The convergence of quantum, inflationary, and string-theoretic multiverses creates a layered framework of possibilities. A single universe may host quantum branching, producing countless alternate histories. Inflationary bubbles may generate separate regions with distinct properties. String-theoretic branes and extra dimensions introduce a higher dimensional multiplicity of entire universes. Together, these models suggest a cosmos of extraordinary richness, a vast ensemble of realities where physics, life, consciousness may manifest in endlessly varied forms. Contemplating such multiverses inevitably provokes existential reflection. If alternative versions of ourselves exist elsewhere, making different choices, then individuality becomes relative rather than absolute. Our decisions, experiences, and lives are unique locally, yet part of a grand, branching ensemble. This realization can evoke both awe and humility, as we confront the multiplicity of existence and the scale of reality far beyond our immediate perception. Finally, imagining multiverses through visualization and meditation can be both intellectually stimulating and emotionally grounding. Picture yourself floating among branes, witnessing the subtle vibrations of strings shaping diverse universes, or drifting through the bubbles of eternal inflation, each a cosmos unto itself. The mind learns to embrace possibility, fluidity, and scale, while the heart experiences wonder at the vastness of reality. The multiverse becomes not merely a scientific hypothesis, but a conceptual space for exploration, imagination, and reflection. In this second part of the chapter, we have examined string theory, extra dimensions, and parallel universes, exploring how these frameworks expand the notion of reality beyond a single universe. We have seen how the fabric of space, the vibrations of strings, and the geometry of higher dimensions can produce a multiplicity of universes, each potentially hosting alternate physical laws and versions of ourselves. The multiverse emerges as both a scientific and philosophical frontier, challenging perception, intuition, and imagination. As we conclude our exploration of multiverse theories, one of the most compelling and deeply personal questions emerges. Do alternate versions of myself exist in other universes? This inquiry bridges the realms of physics, philosophy, and human imagination. The notion that countless versions of our lives unfold in parallel realities challenges our understanding of identity, choice, and fate. To engage with this question, we must weave together insights from quantum mechanics, cosmic inflation, and string theory, creating a conceptual map of alternate selves within the vast expanse of the multiverse. From the perspective of quantum mechanics, each quantum event generates branches of reality. If we extend this principle to macroscopic systems, then theoretically, there exists a universe for every possible outcome of every decision we make. In one branch, you chose one career. In another, a completely different path unfolded. In some universes, minute variations accumulate over time, producing radically different lives, while in others, only subtle differences distinguish alternate selves. The sheer multiplicity defies conventional intuition, an infinite tree of possibilities, each branch hosting a version of you, living a life consistent with that branch's history. Cosmic inflation further amplifies this perspective. If our universe is one bubble among countless others in an eternally inflating multiverse, Then entire universes could exist where the distribution of matter and energy mirrors our own, down to atomic configurations, planetary systems, or even conscious beings. In this framework, your alternate self is not merely hypothetical. Somewhere, under identical or near-identical cosmic conditions, a version of you may indeed experience life along a path analogous to your own. Inflationary bubbles allow for both near copies and wildly divergent variations. Expanding the arena of possibility to staggering scales, string theory adds yet another dimension to this contemplation. In higher dimensional space, brain universes could host variations of reality that differ in subtle or dramatic ways. A version of you could inhabit a universe with slightly different physical laws, alternative particles, or varying constants, shaping experiences that are simultaneously familiar and alien. These higher dimensional possibilities suggest that alternate selves are not restricted to small divergences. They might inhabit realms governed by entirely new physics, exploring realities our senses and instruments cannot perceive. The concept of alternate selves invites deep philosophical reflection. Are these versions truly you, or are they distinct consciousnesses arising from similar initial conditions? If identity is tied to memory, experience, and perception, then each branch contains an autonomous self, yet all are intimately connected through shared origin. From this vantage, the multiverse becomes a mirror, reflecting infinite possibilities and variations of existence, where every choice, hesitation, and impulse generates ripples across reality, creating endless alternate histories. Mathematics supports these contemplations in astonishing ways. In an infinite or sufficiently vast cosmos, every possible configuration of particles will repeat somewhere, given enough space and time. Your home, your planet, or even your body could be instantiated multiple times in separate regions, each forming an alternate universe. In quantum terms, the branching occurs continuously. In cosmological terms, the repetitions arise from spatial vastness. Together, these frameworks suggest a near-limitless set of other yous, each as real as the one experiencing this moment. This perspective can evoke both wonder and existential vertigo. The idea that innumerable versions of ourselves exist, making different choices and experiencing alternate outcomes, challenges the uniqueness of our lived experience. Yet it also invites humility. Our existence is part of a vast, branching cosmic story, interwoven with infinite possibilities. While we remain confined to our local perspective, the multiverse expands the conceptual boundaries of what it means to live, decide, and exist. Meditatively imagining alternate selves can be transformative. Picture countless versions of yourself, each navigating a universe shaped by distinct conditions. Some are familiar, some are unrecognizable. Observe the convergence and divergence of possibilities, appreciating that every life is a manifestation of fundamental laws, probabilities, and cosmic structures. This visualization fosters both curiosity and serenity, allowing the mind to inhabit vast scales while maintaining focus on personal presence. Contemplating alternate selves also reframes choice and consequence. In a multiverse where every possible decision occurs somewhere, the absolute weight of any single choice is softened. Yet each branch is real and consequential within its context, emphasizing responsibility, creativity, and engagement. You exist at the intersection of chance and determinism, creating a narrative that is uniquely yours while simultaneously part of an infinite ensemble. The multiverse perspective deepens our understanding of existence itself. Life, consciousness, and experience are not isolated phenomena, but emergent properties within a vast, interconnected framework of realities. Alternate selves are reflections of the same underlying principles: matter, energy, probability, and the curvature of space-time. whether these selves are directly observable or forever beyond our reach. They underscore the richness and complexity of a cosmos that transcends singularity and embraces multiplicity. In closing, the question of alternate selves illuminates both science and imagination. It bridges physics and philosophy, inviting us to consider the interplay of choice, probability, and cosmic structure. Whether realized through quantum branching, inflationary bubbles, or brain landscapes, the existence of other use emphasizes the vastness, beauty, and mystery of the universe. It transforms curiosity into contemplation, exploration into meditation, and speculation into a profound engagement with the nature of reality. As we conclude this chapter, let us carry forward the vision of a multiverse that is simultaneously scientific and experiential, infinite yet structured, mysterious yet approachable. The cosmos, with its branching possibilities and alternate selves, becomes not only an object of study, but a canvas for reflection, imagination, and awe. In this landscape of endless worlds, our lives are both unique and interconnected, grounded in local reality, yet part of an expansive, multifaceted, holy universe of universes where every version of existence finds its place. As we continue our cosmic journey, we arrive at the profound and contemplative topic of the end of the universe. While we have explored beginnings, multiverses, and the unbounded nature of space, the universe's ultimate fate challenges our understanding of time, energy, and entropy. One of the most widely discussed scenarios is the Great Freeze, or heat death, which envisions a future dominated by thermodynamic equilibrium, where the universe slowly winds down into a state of uniform, minimal energy. To comprehend this concept, we must begin with entropy, a central principle in thermodynamics. Entropy measures the degree of disorder or randomness in a system. In everyday life, we observe entropy as processes that move from order to disorder. Ice melts into water. Buildings deteriorate, or fuel burns to release energy. On a cosmic scale, entropy governs the universe itself. Stars burn their fuel. Galaxies evolve, black holes form, and over immense spans of time, energy is distributed more evenly. Approaching maximum entropy, the heat death scenario predicts a universe in which all usable energy is exhausted. Stars will burn out, black holes will evaporate via Hawking radiation, and matter itself may decay. No temperature gradients will remain to drive physical processes, meaning that motion, life, and structure cease. The cosmos will become a cold, dark expanse, stretching infinitely but devoid of dynamic activity. This is a universe where entropy reigns supreme and the arrow of time loses practical meaning. As change slows to near-STAs. One way to visualize the Great Freeze is through a meditative exercise in imagination. Picture the night sky billions upon billions of years into the future. Galaxies are faint, dim points scattered across a vast darkness. Stars no longer shine. Planets have long since cooled, and black holes gradually emit their final quanta of energy. Light itself diminishes as sources fade away, leaving a cosmic canvas of stillness and silence. The universe has reached a state of equilibrium where no events can occur, no life can persist, and time flows without consequence. The implications of heat death are both scientific and philosophical. Scientifically, it reflects the second law of thermodynamics applied on a cosmic scale. Energy tends toward uniform distribution, and isolated systems evolve toward equilibrium. Philosophically, it evokes a vision of impermanence and the finite duration of dynamic existence. Despite its immensity, the universe is not eternal in the sense of persistent activity. All structures, from galaxies to atoms, are subject to gradual decay. In this context, existence itself becomes an ephemeral phenomenon, fleeting yet extraordinary. Consider the timeline of cosmic evolution leading to heat death. First, stars exhaust their nuclear fuel, becoming white dwarfs, neutron stars, or black holes. Galaxies drift apart due to cosmic expansion, leaving vast, empty regions between them. Black holes gradually evaporate via Hawking radiation, releasing energy in infinitesimal amounts over unimaginable timescales. Eventually, all matter may decay into subatomic particles, leaving a nearly featureless universe. Even the fabric of space-time itself may stretch endlessly under accelerated expansion, reinforcing the sense of ultimate stillness. Heat death also invites reflection on life and consciousness. If the universe trends inevitably toward stasis, the window for life is finite. Civilizations, planets, and ecosystems occupy fleeting moments within cosmic time. This understanding can inspire both humility and urgency. Our existence is precious, precisely because it is temporary, embedded in a vast, evolving cosmos. It encourages contemplation of the ephemeral beauty of stars, the significance of knowledge, and the enduring impact of conscious thought. Even in a universe destined for silence, the scenario of the Great Freeze may seem gloomy, yet it is not devoid of wonder. The gradual transition to equilibrium is a process of remarkable complexity and order. Stars form and die. Black holes interact, and galaxies dance across the cosmic stage for billions of years. The universe's journey toward heat death is a slow unfolding of physical laws, a demonstration of the elegance of thermodynamics writ large. In this sense, the end is not abrupt, but a meditation on time, scale, and the relentless flow of energy, cosmic. Expansion plays a critical role in this scenario. Observations indicate that the universe's expansion is accelerating, driven by dark energy. As galaxies recede beyond each other's horizons, the observable universe for any given location shrinks. Stars become isolated, black holes dominate local regions, and the vast stretches of space grow ever darker. Heat death is not only a function of entropy, but also of spatial separation. The universe becomes cold, empty, and isolated, even as space itself continues to expand. Finally, heat death offers an opportunity for philosophical contemplation. It forces us to confront questions of meaning, impermanence, and the nature of existence. In a universe that will ultimately reach equilibrium, every act, observation, and thought occurs within a limited window of opportunity. This recognition can inspire awe, humility, and a deep appreciation for the fleeting moments of dynamic complexity that define life and consciousness. Heat death is not just a scientific endpoint. It is a meditation on time, the beauty of impermanence, and the cosmic context of our existence. In this first part of Chapter 8, we've explored the Great Freeze scenario, a universe winding down toward thermodynamic equilibrium, where energy is evenly distributed, stars fade, and motion ceases. We have examined the scientific principles underlying this process and reflected on its philosophical and existential implications. Heat death presents a vision of cosmic stillness, inviting both intellectual curiosity and meditative reflection as we consider the ultimate fate of all that exists. Following the concept of the Great Freeze, we now turn to a different vision of cosmic destiny, the Big Crunch. Unlike the slow, silent cooling of heat death, the Big Crunch envisions a universe that eventually collapses upon itself, reversing the expansion we have observed for billions of years. In this scenario, the cosmos does not fade into cold equilibrium, but contracts dramatically, culminating in a dense, high-energy state that may mirror the conditions of the Big Bang itself. The foundation of the Big Crunch scenario lies in the dynamics of cosmic expansion. The universe has been expanding since the Big Bang, with galaxies moving away from each other as space itself stretches. This expansion is influenced by gravitational forces, dark matter, and dark energy. In a universe with sufficient matter density, gravity may eventually overcome expansion. Over unimaginable timescales, galaxies slow, cosmic expansion halts, and then reverses, initiating a collapse toward a singular, compressed state. Visualizing the Big Crunch requires a shift in perception. Imagine the vast cosmos we observe today gradually slowing its expansion. Stars approach one another over eons. Galaxies merge in grand collisions, and space itself contracts. The universe becomes hotter and denser as matter and radiation are compressed. Eventually, every particle, star, and galaxy accelerates toward the center of the collapsing cosmos, forming a singular, ultra-dense environment where conventional physics approaches its limits. The thermodynamics of collapse differ markedly from heat death. Instead of energy dissipating into uniformity, energy becomes concentrated, increasing temperature, density, and interactions in falling matter generates extraordinary gravitational and kinetic effects. Black holes merge, neutron stars collide, and radiation floods the contracting universe. This crescendo of cosmic energy is the antithesis of the slow, cold dissolution envisioned in the heat-death scenario. Physically, the Big Crunch may resemble a reverse Big Bang. In this state, densities and temperatures reach extremes, approaching or exceeding those of the universe's origin. Space-time itself becomes highly curved, challenging our understanding of gravity, quantum effects, and fundamental forces. The universe becomes a compact, fiery singularity, potentially setting the stage for another expansion, an idea explored in cyclic or oscillatory models of cosmology, where universes undergo endless cycles of birth, collapse, and rebirth. The Big Crunch also invites existential and philosophical reflections. In a collapsing universe, impermanence is starkly evident. All structures, civilizations, and galaxies are destined to converge into singularity. Life, in the familiar sense, is finite and temporary, embedded in a cosmic rhythm of creation and destruction. Yet, this vision also conveys a sense of continuity. The end may not be final, but a precursor to a new beginning. It reflects a universe where beginnings and endings are interwoven, cyclic, and deeply interconnected. The scenario emphasizes the delicate balance of cosmic forces. The ultimate fate, heat death, Big Rip, or Big Crunch depends on the interplay between matter density, dark energy, and expansion dynamics. Observations of cosmic acceleration today suggest a universe dominated by dark energy leaning away from a Big Crunch. However, theoretical exploration of collapse scenarios remains valuable for understanding the limits of physics, the possible behaviors of spacetime, and the diverse futures that could await our cosmos. Visualizing the Big Crunch through meditation or imagination can be powerful. Picture the cosmos contracting, galaxies spiraling closer, stars merging in brilliant displays of energy, and light bending under intense gravitational fields. The universe becomes a dynamic, turbulent, and luminous entity, accelerating toward a singular end. Unlike heat death, which emphasizes stillness and quiet, the Big Crunch is a vision of motion, intensity, and cosmic drama, dance of matter and energy converging toward ultimate density. Philosophically, the Big Crunch resonates with cyclical and mythological conceptions of time. Many ancient cultures imagined the universe as a cycle of creation, preservation, and destruction. The oscillatory cosmology of a Big Crunch, followed by a new Big Bang, echoes these archetypal narratives. Time, causality, and existence become less linear and more rhythmic, inviting reflection on the patterns of beginnings and endings that permeate nature and human perception. The Big Crunch also stimulates questions about the origin and destiny of life. If the universe is cyclic, then life may emerge, flourish, and disappear in repeated patterns across cosmic epochs. Our existence gains new significance. We are part of a transient phase within a grander, repeating cycle. Civilizations, stars, and galaxies exist in a dynamic interplay of emergence and collapse, each phase contributing to the larger cosmic narrative. Finally, considering the Big Crunch encourages a meditative engagement with impermanence and continuity. By visualizing the universe's contraction, we confront the fragility of structures, the inevitability of change, and the interplay between entropy and concentration. At the same time, the potential for a subsequent rebirth evokes hope and wonder, suggesting that endings may lead to beginnings, and the cosmos remains eternally dynamic, whether in stillness or motion. In this part of Chapter 8, we have explored the Big Crunch, a universe contracting under gravity, converging toward extreme density and energy. We have examined its scientific basis, physical processes, and philosophical implications. The Big Crunch contrasts with heat, death, offering a vision of cosmic finality that is intense, dynamic, and potentially cyclic, challenging our perception of time, entropy, and the fate of existence itself. As we conclude our exploration of cosmic endings, we arrive at a scenario that is both dramatic and unsettling: the Big Rip. Unlike the slow cooling of heat death or the gravitational collapse of the Big Crunch, the Big Rip envisions a universe torn apart by accelerating expansion. In this model, dark energy grows in strength over time, eventually overwhelming all forces that bind matter together, from galaxies and stars down to atoms themselves. The universe, in essence, is stretched to infinity, leaving nothing intact. The Big Rip scenario arises from observations of cosmic acceleration, first discovered in the late 20th century through the study of distant supernova. Dark energy, the mysterious force driving this acceleration, constitutes roughly 70% of the universe's total energy density, while current measurements suggest a relatively stable rate. Theoretical models allow for a form of dark energy called phantom energy, whose density increases over time. In such a universe, the expansion is not just persistent. It intensifies, accelerating toward a singular, catastrophic endpoint. Visualizing the Big Rip is both awe-inspiring and terrifying. Initially, galaxies drift apart faster than light can, traverse the space between them. Then, gravitationally bound systems, galaxy clusters, solar systems, planets begin to unravel. Stars are torn from their orbits, planets are ejected or disintegrate, and finally, atomic bonds themselves are overcome. Matter, as we know it, ceases to exist in its familiar form. Space itself stretches relentlessly, rendering distances infinite and interactions impossible. Time, as a human observer perceives it, becomes meaningless. The physical processes leading to the Big Rip are extreme. As the universe expands ever faster, the scale factor, a measure of the size of the universe, increases. Without bound, tidal forces grow correspondingly, overwhelming gravitational, electromagnetic, and even nuclear forces. Structures disintegrate sequentially, from galaxy clusters to individual stars, then planets, molecules, and finally atoms. Ultimately, fundamental particles may be isolated in a vast, rapidly expanding void, an endpoint beyond comprehension and observation. Philosophically, the Big Rip evokes reflections on impermanence, fragility, and cosmic inevitability. Unlike heat death or the Big Crunch, where processes unfold gradually or cyclically, the Big Rip represents abrupt and violent dissolution. It reminds us that existence, matter, and life are contingent upon delicate balances of physical laws. The universe in this vision is not only finite in its capacity to sustain structures, but also dramatically vulnerable to the properties of fundamental forces. This scenario challenges our notions of permanence and stability at the largest scales. The Big Rip also offers an opportunity to meditate on cosmic perspective. From our vantage point, the night sky appears serene, orderly, and vast. Yet billions of years into the future, even these comforting constants may be destroyed. This realization encourages humility and awe, emphasizing the fleeting nature of perceived stability. It suggests that our lives, choices, and civilizations exist within a fragile cosmic framework, where even galaxies and atoms are miniature in considering the Big Rip. We confront the role of dark energy in shaping destiny. This enigmatic force is both the architect of cosmic structure and the harbinger of ultimate destruction. Its influence underscores the profound interplay between observable phenomena and unseen forces. The universe's fate depends on parameters we can measure but do not fully understand, reminding us of the limitations of knowledge and the mystery of existence. In this sense, cosmology becomes not only a scientific pursuit, but a philosophical reflection on uncertainty, contingency, and the power of invisible agents shaping reality. Beyond physics, the Big Rip invites contemplation of cosmic fate and human meaning. In a universe ultimately destined for annihilation, our experiences, knowledge, and achievements acquire a temporal, delicate quality. The ephemeral nature of life becomes apparent in the context of cosmic evolution. Yet, recognizing this impermanence does not diminish significance. On the contrary, it elevates the beauty of existence, fleeting, precious, and extraordinary precisely because it exists in a vast, dynamic cosmos subject to forces far beyond our control. The Big Rip also intersects with questions of time and causality. As the universe tears apart, causal connections vanish. Events become isolated, interactions impossible, and even the flow of time, defined by change and observation, loses meaning. This leads to profound reflection. If all temporal structure collapses, what does it mean for existence, consciousness, or perception? Here, physics and philosophy converge, as cosmologists and thinkers alike confront the nature of reality when conventional rules no longer apply. Finally, reflecting on the Big Rip encourages acceptance and wonder. The universe's ultimate fate, whether it is freeze, crunch, or rip, remains uncertain. Yet contemplating these possibilities cultivates a sense of awe, perspective, and connection to the cosmic story. We are participants in a vast narrative, witnessing a chapter of the universe's life while imagining its potential endings. The contemplation of endings, whether silent, cyclical, or violent, offers a lens through which to appreciate beginnings, life, and the fragile beauty of existence. In conclusion, the Big Rip scenario presents a universe dramatically torn apart. By accelerating expansion, where matter, structures, and even fundamental particles are ultimately disrupted. Coupled with philosophical reflections, it emphasizes impermanence, cosmic fragility, and the limits of human perspective. Alongside heat death and the Big Crunch, the Big Rip expands our understanding of cosmic destiny, offering both scientific insight and profound meditation on existence. It challenges us to reflect on the fleeting, precious nature of life while marveling at the grandeur, complexity, and mystery of the cosmos. As our journey through the cosmos continues, we encounter a concept that challenges both science and the human psyche: infinity. While stars, galaxies, and even universes can be measured and observed, infinity exists as a notion beyond empirical comprehension. Confronting infinity provokes profound psychological reactions: wonder, awe, fear, and sometimes existential disquiet. How does the human mind process the concept of something without end, a continuum that defies finite understanding? This question lies at the intersection of cosmology, psychology. From a psychological standpoint, the mind struggles to conceptualize the infinite because it is wired to perceive boundaries, limits, and measurable quantities. Every experience, memory, and observation occurs within a framework of beginnings and endings. Infinity, by its very nature, has no start or stop, no edges or measurable endpoints. This dissonance can provoke a cognitive tension. Humans are both fascinated by and intimidated by unboundedness. When faced with the idea of an eternal universe, infinite galaxies, or countless parallel worlds, the mind experiences both awe and vertigo, a simultaneous appreciation of beauty and a confrontation with the incomprehensible. This psychological tension manifests in various ways. Some experience existential awe, a sense of wonderment and reverence for the immensity of reality. Others feel cosmic anxiety, a subtle or profound unease at the realization that their existence is minuscule compared to infinite space and time. These reactions are natural, reflecting the mind's attempt to reconcile its finite perspective with an unbounded universe. Meditative approaches to infinity often involve allowing oneself to feel smallness while embracing the beauty of the infinite expanse, transforming fear into contemplative curiosity. Philosophically, infinity inspires some of humanity's deepest questions about reality and existence. Consider the inquiry: is there always something beyond the next? When contemplating infinite space, time, or universes, one asks whether boundaries are truly absent or merely hidden beyond perception. This question echoes throughout philosophy and mathematics. Infinity challenges notions of causality, beginnings, endings, and continuity. If the universe is infinite, then every possibility is realized somewhere, every question answered somewhere, and yet every answer leads to another horizon of inquiry. Mathematicians have formalized these philosophical intuitions in the study of set theory and transfinite numbers, pioneered by thinkers like Cantor and Hilbert. These abstractions allow the mind to approach infinity conceptually, though not experientially. One can imagine countable versus uncountable infinities, hierarchies of size, and infinite series. Still, the human mind often experiences these ideas as simultaneously enlightening and overwhelming. Infinity, in this sense, is a mirror. It reflects the limits of our cognition even as it expands our imagination. Meditatively, engaging with infinity can be transformative. By contemplating unboundedness, we learn to observe without grasping, to appreciate without controlling, and to exist in the presence of something vastly larger than ourselves. The mind can enter a state of receptive awe where fear dissolves into curiosity, and the magnitude of the universe becomes a source of inspiration rather than terror. Visualizations of endless star fields, infinite timelines, or branching multiverses can evoke a sense of calm, an awareness that life is one pattern among countless possibilities. Infinity also magnifies the contrast between human scale and cosmic scale. Our lives, though meaningful, are fleeting in relation to cosmic time and space. Stars burn for billions of years. Galaxies evolve over epochs far beyond comprehension, and the universe itself may stretch infinitely. Yet, within this immense framework, human consciousness, creativity, and observation acquire unique significance. We are observers of the infinite, capable of reflecting upon it, contemplating it, and deriving meaning from our finite perspective. This paradox, small yet aware, fleeting yet reflective, defines our relationship with the cosmos, psychologically. Grappling with infinity can also encourage humility and perspective. Recognizing the vastness of the universe helps temper egocentric or immediate concerns, placing life, history, and civilization within a broader context. This perspective does not diminish human value, but rather situates it within an extraordinary, ongoing cosmic narrative. By facing infinity, we cultivate both reverence for the unknown and appreciation for the fragile, luminous nature of existence. Fascination with infinity has also inspired art, literature, and culture. Poets, philosophers, and artists have long wrestled with the unbounded, using metaphors of endless horizons, infinite oceans, or eternal light. These creative expressions reflect our psychological need to bridge the finite with the infinite. to give form to concepts that otherwise defy representation. In doing so, they offer both solace and insight, translating the overwhelming vastness of the cosmos into experiences that resonate with human perception and emotion. In this first part of Chapter 9, we have explored how the concept of infinity challenges the human mind. We examine psychological reactions from awe to anxiety, philosophical inquiries about boundaries and endlessness, and meditative approaches that transform fear into contemplation. Infinity magnifies both the fragility and the beauty of human existence, situating life within a cosmic context that is simultaneously incomprehensible and profoundly inspiring. As we move forward, we will delve deeper into the meditative and philosophical dimensions of attempting to understand infinity, exploring techniques to reconcile human finitude with unbounded cosmic scales, and reflecting on the transformative insights that emerge when the mind contemplates what lies beyond all limits. As we continue our exploration of infinity, we enter a space where science, philosophy, and introspection converge. Beyond the cognitive and emotional reactions to the boundless universe, there exists a meditative dimension and approach in which the mind observes infinity not as a problem to be solved, but as a phenomenon to be experienced. This perspective transforms fear or confusion into contemplation, curiosity, and profound awareness. Meditative engagement with infinity begins by quieting the mind, allowing thoughts to slow and attention to expand outward. Visualization exercises can be particularly effective. One might imagine gazing into a night sky with billions of stars, each a distant sun, each potentially hosting countless worlds. As awareness grows, the mind extends beyond observable galaxies to the unobservable, conceptualizing realms that may exist far beyond the cosmic horizon. This mental exercise cultivates both humility and wonder, inviting the observer to exist in a state of receptive awe rather than analytical control. This meditative approach has practical benefits for psychological well-being. By focusing on the vastness of space and time, individuals can gain perspective on their own lives, concerns, and challenges. Daily stresses, social hierarchies, or personal anxieties are seen in the context of a universe that is immensely larger, older, and more complex than any individual experience. Such perspective does not diminish the value of life. Instead, it fosters resilience, equanimity, and appreciation for the fleeting moments that constitute human existence. The act of contemplating infinity also enhances creativity and abstract thinking. When the mind navigates scales beyond ordinary experience, conventional boundaries dissolve, ideas flow more freely, and connections between disparate concepts emerge. This mental expansion can inspire philosophical insights, artistic expression, and even scientific inquiry. Many mathematicians and cosmologists report that meditative reflection on vast scales has prompted breakthroughs in understanding complex concepts, from infinite series to cosmological models. Yet, alongside inspiration comes the humbling realization of human smallness. The universe is vast beyond imagination. Billions of galaxies, each containing billions of stars, each potentially hosting innumerable planets. Cosmic time spans billions of years, dwarfing the brief few decades or centuries of human life. Recognizing this scale can evoke a sense of insignificance, a feeling that individual existence is almost negligible. Paradoxically, this awareness can also be liberating. By situating oneself within the cosmic panorama, petty worries and egoic concerns lose disproportionate weight, creating mental clarity and openness. The sense of smallness is further amplified when contemplating phenomena such as cosmic inflation, dark energy, and multiverse possibilities. These concepts suggest that the observable universe is but a tiny fraction of a much larger, perhaps infinite reality. The number of potential worlds, timelines, and configurations may be beyond counting, highlighting the remarkable rarity and fragility of life as we know it. Yet, within this context, conscious beings gain a unique position: the ability to observe, reflect, and derive meaning from an otherwise indifferent cosmos. Meditation on infinity also encourages a recalibration of temporal perspective. Human life unfolds over decades, history over millennia, yet these scales are fleeting in comparison to cosmic epics. Stars are born, evolve, and die over billions of years. Galaxies interact and merge over similar timescales. The universe itself may endure trillions or more. Recognizing this disparity fosters a profound awareness of the present moment. Each experience, interaction, and observation becomes a precious window within the flow of cosmic time. Mindfulness of this scale deepens appreciation and gratitude, enhancing the richness of perception. In addition to psychological and temporal benefits, meditative engagement with infinity cultivates ethical and existential insight. When one considers the vastness of the cosmos, questions naturally arise. How should finite beings act in a boundless universe? What responsibilities do we bear to each other, to future generations, or to life itself? Though infinity may elude comprehension, its contemplation can inspire compassion, humility, and a sense of interconnectedness. Recognizing our smallness encourages respect for both the known and the unknown, for life's fleeting beauty and for the structures that sustain existence on a fragile planet. Visualization techniques often incorporate cosmic scales and temporal analogies. One might imagine the Milky Way shrinking into a single dot, then the local group of galaxies, and finally the entire observable universe, compressing into a speck within infinite space. Alternatively, time can be expanded. The lifespan of a star compared to human life, the age of galaxies compared to civilizations, or the universe's expansion compared to planetary history. Such exercises highlight both infinitude and minuteness simultaneously, fostering awe and introspection. Meditative reflection on infinity also nurtures creativity in storytelling, philosophy, and art. Writers, poets, and visual artists often explore themes of scale, time, and boundlessness, translating abstract cosmic truths into human experience. By contemplating the infinite, creators can bridge the gap between human perception and universal phenomena, producing work that resonates emotionally and intellectually. This synergy between meditation and creative expression demonstrates the deep interplay between cognition, emotion, and imagination when engaging with infinity. Ultimately, Part 2 of this chapter emphasizes that infinity is not merely a scientific or mathematical abstraction, but also a psychological and meditative experience. By contemplating the unbounded, humans confront both fear and fascination, smallness and significance, temporality and eternity. Engaging with infinity cultivates humility, wonder, and perspective, offering a lens through which to view our lives, choices, and place in the cosmos. The practice transforms abstraction into lived experience, making infinity a companion to reflection rather than a source of dread. In this part of Chapter 9, we've explored the meditative approach to infinity and the awareness of human smallness. We examined how visualizations, perspective exercises, and contemplative reflection foster awe, clarity, and ethical insight. We also considered how confronting cosmic scale can enhance creativity, temporal awareness, and appreciation for the fragile yet extraordinary nature of life within the infinite expanse of the universe. In the final part of our exploration of infinity and the human mind, we turn to the philosophical dimensions of the infinite, integrating cognitive, meditative, and existential perspectives. Infinity has always challenged thinkers, artists, and spiritual practitioners alike, provoking fundamental questions about existence, reality, and consciousness. As we have seen, confronting infinity triggers awe, fear, and humility, But it also opens doors to deep reflection, ethical contemplation, and profound insight. One of the central philosophical questions posed by infinity is deceptively simple, yet profoundly complex. Is there always something beyond? When considering space, time, or universes, the mind asks whether every boundary is illusory and whether reality itself is layered with successive horizons of unending possibility. This question evokes both wonder and paradox. If something exists beyond the observable, can it ever be known? If the universe is infinite, does each event, thought, and possibility recur endlessly? These queries challenge our understanding of knowledge, perception, and truth. Mathematics and philosophy intersect here, providing tools for conceptualizing the infinite without direct experience. Cantor's transfinite numbers and Hilbert's infinite hotel paradox illustrate how infinity defies intuition. A hotel with infinitely many rooms can accommodate additional guests without ever being full, demonstrating a type of logic that feels alien to our finite minds. Such abstractions allow us to explore infinity structurally, revealing patterns, hierarchies, and properties that challenge ordinary cognition while inspiring intellectual curiosity. Yet the meditative approach provides a complementary, experiential pathway. Rather than trying to compute or measure infinity, the meditator seeks to exist within it. Practices often involve visualization, breathwork, or mindful reflection on cosmic scale. One might imagine oneself drifting among stars, floating beyond galaxies, or witnessing the endless stretching of space-time. In this context, infinity becomes not an object to analyze, but a state of consciousness to inhabit. The mind learns to hold paradox, to dwell simultaneously in the vast and the minute, the temporal and the eternal. Meditation on infinity can produce profound psychological effects. It often cultivates equanimity, as the mind internalizes the relative insignificance of personal concerns within the vast cosmic tapestry. Anxiety about trivial matters diminishes when juxtaposed with the immensity of time and space. Simultaneously, such contemplation nurtures gratitude and wonder. Life, though brief, becomes a luminous occurrence within a universe of unimaginable scale. Humans learn to accept impermanence, embracing both the ephemeral and the eternal aspects of existence. Philosophically, infinity also encourages ethical reflection. If the universe is boundless and human life is transient, how should one act? How should civilizations behave, knowing that their achievements, creations, and legacies exist temporarily in a vast cosmic framework? Meditation on infinity fosters empathy, humility, and stewardship, suggesting that ethical behavior derives not only from immediate concerns, but also from recognition of one's place within an immense, interconnected reality. Engaging with infinity in this way is deeply transformative for creativity and imagination. Artists, writers, and thinkers throughout history have used the infinite as a lens to expand perception and expression. Infinite landscapes, recurring patterns, and cosmic cycles appear in literature, music, visual arts, and architecture. By contemplating the unbounded Mosey creators access insights and narratives that exceed conventional experience, translating the abstract vastness of the universe into forms that resonate emotionally and cognitively. Infinity also invites reflection on existence itself. If time, space, or universes are unbounded, then the concepts of beginnings, endings, and causality become fluid. Every ending may contain seeds of renewal. Every beginning may emerge from a prior infinite context. Human consciousness, with its finite span, exists within these patterns, capable of observing, reflecting, and meaning-making. This interplay between the finite and infinite mirrors philosophical traditions emphasizing paradox, interconnectedness, and cyclical reality, from Eastern cosmologies to Western metaphysics. Furthermore, meditation on infinity can foster deep psychological insight and self-awareness. When contemplating the infinite, the boundaries between self and cosmos blur. Personal identity, typically experienced as distinct and bounded, can be perceived as part of a greater continuum. This dissolution of rigid egoic structures is not nihilistic. Rather, it engenders a sense of belonging, interconnectedness, and participation in the cosmic whole. Such experiences are often described as profoundly calming, enlightening, and spiritually meaningful. As we meditate on infinity, the mind encounters paradoxes and contrasts that deepen understanding. The universe is at once vast and intimate, timeless and fleeting, chaotic and ordered. Stars and galaxies operate according to universal laws, yet the totality of space may be beyond comprehension. Life is momentary, yet consciousness reflects on eternity. These contrasts stimulate philosophical inquiry, encouraging exploration of concepts such as continuity, multiplicity, and the limits of knowledge. Infinity becomes a mirror for self-reflection, a tool for examining both outer reality and inner awareness. In sum, Part 3 of Chapter 9 emphasizes that engaging with infinity is simultaneously a philosophical, meditative, and transformative experience. It challenges cognition, evokes awe, cultivates humility, and deepens ethical and existential understanding. By integrating meditation with reflective inquiry, humans can inhabit infinity without being overwhelmed, transforming abstract enormity into profound insight and lived experience. Finally, this engagement underscores a paradox central to human existence. We are infinitesimally small within a boundless universe, yet capable of contemplating the infinite. Our minds, though finite, possess the ability to envision, reflect, and inhabit realms beyond direct perception. In this space, infinity ceases to be merely an abstract concept and becomes a companion for thought, a source of wonder, and a framework for exploring the mysteries of reality. The contemplation of infinity thus becomes a journey both outward into the cosmos and inward into consciousness itself. As our voyage through the universe reaches its final chapter, we return to the questions that started this journey. Does the universe have boundaries? Is there an edge to the cosmos? Or is it infinite in every direction? After traveling across billions of light-years of thought, from cosmic horizons to parallel universes, and from the philosophical depths of infinity to the contemplative realms of the human mind, we find ourselves circling back to the fundamental mysteries that inspire both awe and serenity. At first glance, the universe seems overwhelmingly vast, even limitless. Astronomers observe galaxies receding at incredible speeds, star clusters stretching across millions of light-years, and cosmic filaments spanning the observable universe. These observations suggest expansion without visible endpoints, a boundless space where every glance into the sky reveals countless stars and galaxies. Yet, paradoxically, the universe may still possess structure and subtle boundaries that are simply beyond our perception. The concept of a finite but unbounded cosmos emerges from this Tenshuna universe that has no edge in the conventional sense but still contains measurable properties, such as mass, energy, and curvature. Modern cosmology offers analogies to help visualize this idea. One of the most effective is the surface of a balloon. Imagine an ant walking along the surface of a balloon. From its perspective, it can continue walking indefinitely, never encountering an edge, yet the surface itself is finite. Similarly, our three-dimensional universe could be finite but unbounded, curving back on itself in ways that are imperceptible to our senses. This perspective transforms the idea of infinity into a more nuanced concept. Perhaps the universe's boundlessness is not about endless space, but a state or condition of continuous expansion and connectivity. Philosophically, this leads to a subtle yet profound shift in understanding. Infinity may not be a physical measurement, but a mode of being. Instead of imagining endless distances or eternal repetition, we can consider infinity as a property of relationships, processes, and continuity. Space expands, stars form and die, galaxies collide. And yet, the processes themselves are ongoing, connected, and interdependent. In this view, infinity is less a spatial boundary than a cosmic rhythm, a flowing, persistent state that transcends conventional limits while maintaining harmony and coherence. Returning to the beginning of our journey, we recognize that the questions we asked about edges, limits, and the ultimate nature of the cosmos are themselves a reflection of human curiosity and consciousness. Our minds naturally seek definitions, boundaries, and conclusions. Yet, the universe resists such confinement, reminding us that understanding is not always about reaching a final answer. Often, the value lies in the exploration itself, the act of observing, reflecting, and allowing ourselves to dwell in wonder. In this meditative and contemplative frame, we can find peace with uncertainty. The lack of clear boundaries or absolute endpoints is not a source of frustration, but an invitation to experience the universe as it is vast, dynamic, and full of possibilities. Infinity, whether conceptual or experiential, becomes a gentle companion. It encourages openness, mindfulness, and appreciation for both the observable and the unseen. By letting go of the need for closure, we cultivate a sense of serenity, allowing awe and curiosity to coexist harmoniously. This approach also emphasizes the interconnectedness of all cosmic phenomena. Stars are born from gas clouds shaped by gravitational waves. Galaxies emerge from dark matter scaffolds. Even black holes influence the evolution of their surroundings. Each component participates in a dynamic dance, suggesting that infinity manifests as continuous interaction, rather than mere spatial or numerical extremity. By perceiving infinity as a state of ongoing connection, we shift from fear or overwhelm to reverence, recognizing our own existence as a subtle note within a grand cosmic symphony. As we contemplate these ideas, the mind begins to experience infinity in a relaxed and meditative way. Rather than struggling to measure or define the infinite, we allow ourselves to sit with it, to observe its unfolding, and to reflect on our small but conscious presence within it. Stars, galaxies, and cosmic filaments become both symbols of coherence, of boundlessness, and anchors for quiet reflection. This interplay between perception and imagination fosters a sense of calm, transforming the grandeur of the universe into a source of solace rather than anxiety. The act of returning to the beginning also highlights the cyclical nature of understanding. Just as cosmic phenomena follow cycles, stellar lifespans, galactic rotations, expansion, and contraction, our journey through knowledge is itself a cycle of inquiry, reflection, and comprehension. Each return to fundamental questions deepens insight, reminding us that exploration is continuous, and understanding grows incrementally with curiosity, patience, and mindfulness. Infinity, in this sense, is both a concept and a practice, inviting engagement over a lifetime rather than offering finite answers. Finally, part 1 of this chapter establishes the foundation for a peaceful closing by framing infinity as a state, rather than a limit, and by embracing the unknown as part of the cosmic experience. We prepare the mind and spirit for the concluding reflections. The universe, with all its mysteries and expanses, becomes a source of calm admiration, a reminder that existence, though brief and limited, is rich, interconnected, and worthy of profound appreciation. As we continue toward the conclusion of our cosmic journey, we pause to reflect on the experiences and insights that have emerged. Our voyage through stars, galaxies, the depths of cosmic theory, and the infinite possibilities of parallel universes has brought us to a point of quiet contemplation. In this moment, the goal is not to provide answers, but to cultivate a sense of peace, wonder, and acceptance for the unknown. The universe is vast, complex, and in many ways unknowable. Its immense scale can be both daunting and inspiring. To some, the realization that billions of galaxies stretch beyond observation may provoke anxiety. To others, it sparks awe. Yet within this immensity lies an opportunity, the chance to embrace uncertainty and to feel connected to something far larger than ourselves. This is the essence of the peaceful closure we aim to offer, the invitation to dwell in the wonder of existence without needing to resolve every question. One way to experience this serenity is through meditative visualization. Imagine yourself floating above the Milky Way, drifting past luminous stars and swirling clouds of gas. Observe the rhythm of galactic arms spiraling gracefully, the quiet dance of celestial bodies over billions of years. Let the mind absorb the enormity without attempting to control it. Each breath can mirror the slow expansion of the cosmos, each exhale a release of tension, anxiety, or the compulsion to understand everything. This practice encourages a state of receptive calm where the unknown becomes a source of comfort. Rather than fear, we can also consider the philosophical implications of embracing uncertainty. For centuries, thinkers have grappled with the question, how can finite beings live meaningfully in an infinite, largely unknowable universe? The answer often lies in acceptance. By acknowledging that some aspects of reality may forever elude comprehension, humans can shift focus from attempting to control the cosmos to appreciating their experience within it. Curiosity and mindfulness become pathways to fulfillment, guiding attention to the beauty and intricacy of what is directly observable and what can only be imagined. This stage of the journey also emphasizes gratitude for existence. Even as we contemplate the endless stretches of space, the vast ages of cosmic history, and the potential multitude of parallel worlds, we recognize the preciousness of consciousness itself, the ability to observe, reflect, and participate in the universe is a rare phenomenon, a delicate miracle amidst the expanse. By acknowledging this, we cultivate a sense of reverence and a profound appreciation for life, both individually and collectively. As the mind settles into this state, it is natural to experience awe in the presence of the unknown. The universe is full of mysteries, dark matter that shapes galaxies yet remains invisible, the possibility of countless unobserved planets and stars, and even the potential existence of other universes entirely beyond our perception. This vast, unknowable complexity can be overwhelming, but when approached mindfully, it becomes inspiring and humbling. The act of surrendering to the mystery transforms it into a source of quiet joy and contemplative reflection. A peaceful farewell also invites consideration of the interconnectedness of all things. Even as the cosmos stretches into infinity, patterns, laws, and relationships bind it together. Stars influence one another through gravity. Galaxies interact over eons, and cosmic expansion links all regions of space-time. In contemplating these connections, humans may experience a sense of belonging, a recognition that even the smallest individual lives and choices participate in a vast, dynamic, and beautiful system. This awareness fosters calm, humility, and contentment. Furthermore, the universe's mysteries provide fertile ground for imagination. As we let go of the need for definitive answers, the mind can explore scenarios freely. Distant civilizations, exotic forms of life, or unimaginable cosmic phenomena, the infinite possibilities, rather than creating anxiety, become a canvas for contemplation and creativity. In this light, the unknown transforms into an alaya companion for reflective thought, meditative observation, and gentle curiosity. To deepen this sense of peace, it is helpful to align breathing and awareness with cosmic scale. Imagine each inhalation drawing in starlight, each exhalation sending thoughts into the vastness of space. Feel yourself as a point within a grand cosmic dance, neither lost nor dominant, but part of a rhythm that stretches across light years and epochs. Such exercises bridge the gap between human finitude and cosmic infinity, creating a tangible connection to the universe while maintaining tranquility and centeredness as we approach the final moments of this meditative journey. We also acknowledge the emotional richness of confronting the unknown. The mix of awe, serenity, and reflection mirrors the universe itself, vast, dynamic, and beautifully complex. It is in this state that the human mind achieves a form of harmony with the cosmos' quiet understanding that uncertainty is not an absence of meaning, but a space for contemplation, wonder, and inner peace. Finally, this part encourages the viewer to carry forward a sense of serenity and admiration beyond the duration of the video. The universe, with all its mysteries, expansions, and potential infinities, need not overwhelm the spirit. Instead, it can invigorate curiosity, inspire mindfulness, and foster a lasting appreciation for the grandeur of existence. By embracing uncertainty, marveling at scale, and reflecting on interconnectedness, one finds a tranquil resonance with the cosmos, a peaceful coexistence with the unknown. As we reach the conclusion of our 3-hour journey through the cosmos, it is time to offer a final reflection, a gentle closure that honors both the grandeur of the universe and the human experience of wonder within it. Throughout this voyage, we have explored the edges of the observable universe, meditated on the nature of infinity, traversed hypothetical multiverses, and contemplated the philosophical implications of the cosmos. Now, in this last segment, we focus on serenity, awe, and appreciation for the mysteries that remain beyond our grasp. The universe, in its vastness, invites both curiosity and humility. Billions of galaxies stretch beyond observation, yet each one is part of a coherent and beautiful cosmic tapestry. Stars form and die, black holes shape galaxies, and cosmic expansion continues relentlessly. These processes occur on scales far beyond human comprehension, yet they unfold with elegance and order. By observing this majestic complexity, we cultivate a sense of reverent awe, an understanding that existence itself, in its infinite variety and duration, is a profound and beautiful phenomenon. In the face of the unknown, the mind can find tranquility rather than fear. Much of human anxiety arises from uncertainty and the desire to control outcomes. The cosmos, by contrast, is indifferent to human concerns. Yet this indifference is not hostile. It is liberating. By acknowledging that the universe operates according to its own principles, independent of human expectation, we can release tension and surrender to the flow of existence. This surrender is not resignation. It is an active choice to inhabit a state of peaceful awareness, accepting that not all questions require answers. Meditative visualization enhances this serenity. Imagine floating through space, gliding past countless galaxies, each glowing with the light of millions of stars. Observe nebulae swirling in brilliant colors, black holes bending light, and distant quasars shining across billions of years. Let your mind follow these cosmic pathways without trying to measure or limit them. With each breath, expand awareness to encompass both the infinite distances and the temporal vastness of cosmic history. This exercise fosters calm, wonder, and a sense of unity with the larger cosmos. As we embrace the unknowable, the concept of infinity becomes not intimidating but comforting. Infinity is less a physical boundary than a reflection of possibility, continuous process, a state of existence, a flow of time and space. Recognizing this, the observer can experience both detachment and engagement. Detachment from the illusion of control. Engagement with the marvel of being alive within such an expansive reality. Infinity becomes a companion for contemplation, a constant reminder that the universe is far grander than our immediate perception. The closing reflection also invites a sense of gratitude. Humanity exists at a unique vantage point, capable of observing, reflecting, and understanding even a fraction of the cosmos. This consciousness, fleeting though it may be, allows us to witness the unfolding of galaxies, to marvel at the birth of stars, and to ponder the potential of multiverses. Each moment of awareness becomes precious, a luminous point of experience. Within the vast canvas of space-time, gratitude for this opportunity fosters emotional well-being and inner peace, connecting the observer to the cosmic whole. Alongside gratitude comes humility, a recognition of our smallness in relation to the cosmos. Human life, civilizations, and even planetary histories are ephemeral in cosmic terms. Yet this smallness does not equate to insignificance. Our capacity to reflect, to question, and to experience wonder is itself a remarkable aspect of existence. In this sense, humility does not diminish value. It enhances appreciation, placing life in the broader context of cosmic continuity and interconnection. A profound lesson from this journey is that mystery is a source of beauty and inspiration. The unknown, be it dark matter, the edges of the universe, or the potential existence of parallel realities, it's not something to be feared, but something to admire, contemplate, and respect. The universe's mysteries encourage imagination, philosophical inquiry, and meditative reflection. They remind us that life, though temporary, is part of an endlessly fascinating and interconnected cosmic story. This final part also emphasizes a balance between contemplation and serenity. While curiosity drives exploration and inquiry, the experience of awe and wonder allows the mind to rest in the presence of infinity. One can admire the grandeur of space without needing to resolve every question or solve every paradox. This balance is crucial for cultivating a lasting sense of inner peace, enabling viewers to carry the experience beyond the confines of the video and into their daily lives. As we prepare to end our journey, imagine a gentle descent from the stars, returning inward while retaining awareness of the cosmos. Feel the vastness of space around you, yet notice the quiet centeredness within. Let the mind hold both scales, simultaneously the infinite and the intimate, the expansive and the immediate. This dual awareness embodies the core lesson of our journey. The universe is both incomprehensibly vast and profoundly accessible through reflection, mindfulness, and imagination. Finally, take a moment to savor the interplay of wonder and calm. The universe may never reveal all its secrets, yet in its silence and mystery lies profound beauty. By embracing the unknown, acknowledging our smallness, appreciating the gift of consciousness, we arrive at a state of cosmic serenity. This is the essence of the closing message: to rest in awe, to experience peace, and to carry forward a sense of connection to the infinite cosmos that surrounds and contains us.